When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care. Quality education is a cornerstone of a thriving, prosperous society. However, the South African education system is under strain, necessitating the work of the Awqaf South Africa Education Waqf to help ease the pressure. Our Matric Mathematics upgrade project alone has already impacted the lives of over 6,000 matriculants. At the Darul Arqam High School in Mitchell's Plain, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience. With the very first word of the Holy Quran being revealed as Iqra, read, educating our community is an act of faith. With your help, we can transform many more lives. Awqaf South Africa, share the care.
We begin in the name of God. We glorify Him and we praise Him. We ask God to bless us with a program that is beneficial to all learners across South Africa. And we also like to thank the teachers and also the administrators for also being so helpful. We would love for all of the grade 12 learners to perform very well in this examination, and this is going to contribute towards South Africa's success. Sawubona, Molo, Goeiemorgen, Sanibonana, Goeiemorgen, Namaste, and Assalamu alaikum wa rahmatullahi wa barakatuh. A warm welcome to you, all of the participants that have logged on across South Africa. A warm welcome from the Okaf SA team as well as the iSkills team. To all of the learners that are joining us from Cape Town, Eastern Cape, Johannesburg, Pretoria, Ladysmith, Polokwane, Limpopo, the list goes on from across centers even as far as Namibia. A warm welcome to you. So just some feedback. Yesterday we hosted the Maths Paper 1 workshop. We had about 15,000 YouTube views. We had up to about 7,000 registered participants. So with this program, we hope to be breaking records and setting more records. So let us know in the comments below where you are connecting to us, from which city, which school are you connecting? Are you happy to be here? Please give us your comments and your feedback. My name is Hassanin Abdullah and I'm the project coordinator for Okaf South Africa. Okaf South Africa is a development organization, and through our sustainable projects, we have been assisting to build South Africa. We share the care through the following projects. We share the care through restoring eyesight to people that are perhaps partially blind due to cataracts and glaucoma. We do this through our cataract removal operation. We also share the care through providing water to water-stressed communities. We also produce books talking about the stories of our struggle stalwarts and our leaders. And we bring youth from all corners of South Africa, from different color and creeds, and they are united through the platform of sport. And this is through our Okaf SA Youth Cricket Tournament. What we have identified that as a society, South Africa, we perform very poorly in mathematics, and this is why we have embarked on a program to uplift the grade 12 learners and their understanding of mathematics. So since 2016, we have been using the services of Mr. Khota from Kway Maths to tutor grade 12 learners at different times of the year as a build-up to the final examination. And this online workshop is part of that project to upgrade the performance of our grade 12 learners. We believe that the future is in STEM, in science, and maths. So with good performance in maths, we as South Africa, we can move forward. We could be producing some scientists and IT engineers from this maths workshop, God willing. So this session is hosted on Okaf SA's YouTube page. So this session you can go back to and refer back to this video the moment the session is over. These videos are on Okaf SA's website, okafsa.org.za. I will be sharing that address details as well. So do not fear if you are experiencing slow internet connectivity. You can always log back on. The video will be there. And if you, as part of your revision for the final exams, if you missed anything, you can go back to the video, you can pause, you can forward, you can go back. So rest assured that we do have this resource for you. Please connect with us via social media on our Facebook, Instagram, LinkedIn, or Okaf SA or Okaf South Africa. Please subscribe to our YouTube channel so you will be informed of future programs. We had yesterday and today also, we're going to call on a representative from the Department of Basic Education, and that's Mr. Leonard Ndau. The Department of Basic Education has been a partner to this program for many years, and they've also been very instrumental in informing lots of these schools across South Africa, and more importantly in Johannesburg. So we're gonna call on Mr. Leonard Ndau. He actually spent most of his day, the better part of yesterday, with us during this program. So we're going to call on Mr. Leonard Ndau, and he's going to give us just a few minutes as part of a welcome. Good morning to you, Mr. Leonard. I'm so pleased that you're spending your weekend with us during the Maths Online workshop. Please do let us know, what was your experience like yesterday? You spent most of yesterday with us during the course of this session. Do let us know, and the floor is yours.
Good morning, Mr. Abdullah. Good morning to our learners, our teachers, and parents at home. My name is Khumani Ndau from the National Department of Basic Education. From what I have observed yesterday is that our teachers have done wonders. We should like to thank them for the efforts that they have done throughout the whole year. Our learners can able to correct us where we are doing mistakes, where we couldn't put correct roots for yesterday's solution. They managed to correct us, which shows that no, these learners are ready to write their final exams. So from what we have also observed and noted greatly is that from the comments which learners had been sending yesterday, we had noticed that no ways there will be learners who will score 100%. And our aim is to have at least a pass of 40%, and which we have observed from yesterday's presentations, comments, and how learners were answering that no, our learners are really, really ready, and they're just mopping up here and there. We couldn't finish off sequences yesterday, which is a topic that we'll start with today. And then from there is then that we'll get into paper two's topics. You know, we start with statistics, the format of the exam. It's lovely. You'll love it. Analytical geometry, heights and distances, trigonometry, and Euclidean geometry. Remember, you should expect questions that will require you, that will require bookwork, require you to prove some of the theorems, to reproduce them. Expect those type of questions. Minimum marks is 15. Expect them. They are coming. Other than that, I would not like to repeat what we have said yesterday. This session, together with Awqaf South Africa, is to make sure that we revise what we have done with your teachers by mopping up, by revising, giving you few questions, giving you enough time to answer questions, and then you relate our solutions with what you have written. You mark your work, correct where you have done mistakes, and on your own after that, revise, redo them, replay these videos, and make sure that you have understood everything, because we are covering in each and every topic what is coming. I assure you, what we are doing are coming. It's just that, you know, maths is maths. We can't just ask you exactly what we have taught you, because the aim of the subject is to test, to gauge, to check if you have understood the concept and if you can able to solve real life problems on your own. That is the main of teaching you the way we are teaching mathematics today and tomorrow. I mean, yesterday and today. So be with us. Don't just wait for us to provide you with the answers. Write them, work them out on your own. Will give you sufficient time to work them out. And then if you get stuck, if you have got challenges, if you want to ask questions, the floor is there. Floor is yours. We are giving you the opportunity to ask questions, and we'll explain them in depth so that you don't make mistakes in future. I wish you well. Thank you.
Mr. Madhav, approximately how many learners do you estimate are now part of our program today?
We are estimating 200,000. The reason being that learners who are, or if you can just notice that it's one online connection, you should know that there are schools that are connecting once with more than 100 learners in a hall. That is what I have observed and got from my colleagues who are at different schools as we are speaking. So it's not like 15,000 that you are talking about. The 15,000 and 18,000 connectivity are only the lines that you can able to see. But in terms of individuals who are participating, I assure you there are more than 200,000. Thank you.
Thank you, Mr.
So there we go. That's Mr. Leonard Ndao. We will be resuming shortly. We'll just have a short message from Okaf SA's CEO, Zainul Abidin Kaji, and then Mr. Khota will be joining us after that.
Dumelang Sandonani Goeiemorgen, Assalamu alaikum wa rahmatullahi wa barakatuh. Peace and blessings of the Almighty be on all of you. A very, very warm and hearty welcome to the mathematics class of 2022 and to all those watching this program over our social media platforms. As you know, mathematics is probably one of the most important subjects required for literally any job or profession. Yet South Africa is ranked among the lowest in the world for mathematics education. We are really proud of all of you who have chosen mathematics as a matric subject and also to become proficient at it. We at Okaf South Africa believe that you have the potential to improve your marks dramatically, as has been shown with previous interventions. Without much ado, we are placing our hope and trust in you. You are the future of South Africa. with a strong knowledge base, excellent moral and ethical values. As future leaders, we pray for your success and in making South Africa the best country in the world. We would like to wish all of the grade 12 learners in the country well in their preparation for the final examinations. We would like to thank parents and teachers who have been involved with providing support to our grade 12 learners. And of course, we'd like to thank the Department of Basic Education for helping us facilitate this program. We'd also like to welcome all the 7,000 participants to this program. Thank you and all the best.
So there we go. That was Zainul Abidin Kaji, Awqaf SA's CEO. So we're definitely breaking records and setting new records. So we have about 7,000 learners that are registered. And Mr. Leonard Mdao has said that, look, we could have numbers up to 200,000 learners because lots of the learners are connecting via the classroom, and the classrooms are beaming these sessions out. So without delay, I would like to call on Mr. Khota that, look, this has been a joint effort between Okaf South Africa, Kway Maths, and with the assistance and collaboration with the Department of Basic Education. So Mr. Khota is definitely one of the rising stars of this workshop and our continued intervention to assist matric learners. So recently we hosted a workshop, an in-person workshop in KwaZulu-Natal at the Al-Falah College. It was very well received. Mr. Khota can also give some comment on that. And he's also been featured on a program to assist grade 12 learners, and that has been on Hilal TV, hilal.tv. They've conducted a maths program in collaboration with the sponsor, Cordoba. So, in continuing with the same vein, Mr. Khota plays a very important role in improving the performance of grade 12 learners in terms of their maths, assisting them to understand the subject if they are struggling with it. And this is all done through his very energetic persona. So let's call on Mr. Khota, the man, the myth, the legend. But before we do that, let me just play something. You know, we always have something to get you going. So that's our launch video. Mr. Khota, Assalamu alaikum wa rahmatullahi wa barakatuh. The man, the myth, the legend. Hope that you are well this morning. Are we ready to...
Okay.
Are we ready for the launch, Mr. Khota?
Yeah, we're ready.
Focus,
all systems
focus.
go, all systems go, all systems go. Good morning, good morning, good morning. Assalamu alaikum. Saubona, Dumelang, Goeiemorgen, and hello to South Africa and the world. Nice to see you guys bright and fresh and early on a Sunday morning. And we're all ready and fired up here in studio. We got a full house today. And yeah, we're ready to... I hope everybody now is has overcome their babalas from last night and they are fresh for today. There's our kids there. Say hello, guys.
Can we go a Mexican wave, Mr. K?
Give
Are
them
we ready for
right.
the wave?
Yes,
One,
yes.
two.
They want a wave. So in 3, right? We're gonna do a 3-second. Wait, in 3. Right. 3, 2, 1, go.
Yeah. Another one, Mr. K.
Another one. In 3, 2, 1, go. Go. There we go. Right. Wave to South Africa. Hello, guys. And that's it. Now the feeling in here is electric. Everybody is very excited to get cracking. We're starting off with our 2 Sigma notation questions. And then we kick off into paper 2. We go straight into trigs. The probability and finance I'll leave for the end of today.
Can I just show you the program and just see if we are correct, Mr.
Yes.
Khota?
Yes.
Is that correct?
I don't see it. It doesn't come up.
Oh, okay. So basically, we're doing probability and trigs. We're having a break at 10:30. We're doing analytics and circle analytics. We're having a lunch break and we're doing geometry.
In fact, I'm starting with trigs. I'm starting yesterday with that sequences and series, the two
Okay.
questions, and then I go into trigs. I'm going to leave the probability for last. Then we'll go
Okay.
into trigs after break. In fact, not even after break, before break in our first session.
There we go,
Okay.
Mr. K. Take the show away.
Right. Good morning. Good morning. Good morning. And thank you all for the wonderful feedback that everybody gave yesterday. And Sanin was saying they had over 10,000 comments. Unfortunately, we cannot put everybody's comments. Thank you, Rory Sang. Good morning, everybody. Maslangu, Zazambu, Mtembu, Kani, Sibanda. Let's Dala Math. Guys, let's get started. I saw somebody from United Kingdom early. So people are live streaming from UK. They are live streaming from Europe. They are live streaming from Dubai. They are live streaming from Australia because there's a lot of CAPS learners, that expats who are doing the South African curriculum through Sakai, and they're doing distance education, and from all over the world we got learners. So welcome everybody. Fatima Rashid from Eastern Cape, welcome, welcome, welcome. Homo, shout out Mr. K. Let's get started, guys. Okay, we're starting with one of the questions that came out in the exam paper. So the question was to evaluate. I'm going to improve my handwriting. Give me a second here. Give me a second. I know some people complained a little bit about, I'm trying. I promise you, I'm trying my best. So we got 5,000. I think you can see that quite clearly. N equals 1, 2n plus 3. So take this one down. This one came out of a past paper. Plus, they give you sigma. They tell you 4,999. They tell you n equals 1. They tell you minus 2n minus 1. Evaluate. So evaluate means to calculate. And this was worth 5 marks in your exams. Okay, so another just warm welcome to everybody. Thanks for the show. Thanks for all your comments and only positive vibes. Thank you for the trolls who have just scrolled on by, moved along. Right. We know what we need to do here, guys. We know what we need to do. What I want you to do is I want you to calculate it separately. Calculate that sigma separately. Be careful with the plus or minus sign. Whichever, whether it's plus or whether it's minus, bracket it, please. Just as a process. So do it separately. Do that part separately and do that part separately. You want to kick off? You can start. Fire off, guys. Start your engines. I hope you guys are hydrated and you are fired up. We're going to do 2 sigma questions and then we go straight into paper 2. In fact, what I'll do, I'll touch on the analytics and circle analytics as to what you guys need to know in that, and then we'll hit our trigonometry right through until the end. Trigs is a big topic, guys. You need to make sure you know what you are doing.
Mr.
Okay.
Khota, we're loving your handwriting today.
Are you?
Yes, all of us and the learners.
Are you being sarcastic?
No, we're vibing with your handwriting. I promise you.
Okay.
Learners,
Okay,
just hit us up here. Show some love for Mr. Khota's handwriting.
No,
Gotta
please.
love it.
Right, let's go. Let's go. Right, so what we're going to do now, please, guys, this is finite. I want you guys to identify one thing here. The minute you see a number on the top, you know it's finite. It ends. Both of them are finite. So what we're going to do, we're going to start substituting from the bottom number in. So we're going to have 2 into 1 plus 3. That's your first term. Plus 2 into 2 plus 3. That's your second term. Plus 2 into 3 plus 3. That's your third term. Plus dot, 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 dot. And remember, because it's finite, you got to plug it in. So you're going to say plus 2 into 5,000 plus 3. So let us expand this. 2 plus 3 is 5. 4 plus 3 is 7. 6 plus 3 is 9. Plus dot, 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 plus. And what do we have here? 2 times 5,000 is 10,000 plus 3 is 10,003. And there we go. We've expanded the first. We've expanded the first sigma. Let's expand the second sigma. And let's call that equation number 1 or expression number 1. We're now going to expand the second one. We're now going to plug in 1. Right? For which one? No, it's fine. I'm just doing it slightly different. I'm doing it slightly different. Right? He's got one way of doing it. My colleague here in class is also another potential A student. So we got -2 into 1 minus 1. Then we got -2 into 2 minus 1. Then we got -2 into 3 minus 1. Dot, 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 dot. And then you got -2 into, let's take 4,999 and plug it in. Let me just see, where is my bag? Okay, give me your calculator there. So 2 times 4,000, and so -2 times 4,999 minus 1. And we get -9,000. So it's -2 into 4,999, right? Minus 1. There we go. So let's expand this. -2 minus 1 is how much? -3. -4 minus 1 is how much? -5. -6 minus 1 is how much? -7. Now it will continue like that. And then we've got -9,999. Right, so we got expression number 1, expression number 2. I'm just going to do it in a different color. So let's go expression number 1. I'm doing that one. So we're going 5 plus 7 plus 9. You know it's arithmetic. 5 plus 2 is 7. Plus 2 is 9. Plus, and what I'm going to do, I'm going to put in my last 3 terms here. So remember, 10. So let's just say we got plus 10,003 here. We got 10,003. The term, oopsie, that's a very ugly 3. People will
Question.
complain. Okay, give me a second. Let's check. Question. Yes, you get penalized for not expanding the notation. 100%. Miss Gumedi, you get penalized. You have to expand. They give you marks for expansion. So remember, there's a common difference of 2. So this term here will be 10,001. And then this term here will be 9,999. Now, why am I going backwards? Because I got a 9,999 and I'm adding the 2. So now we got -3. There we go. So this was 1. This was 2. -3, -5, -7, -9. Then you're going to get -9,999. And that's your last term. So that's where it stops. Now we're adding the 2. The question says add. Please be careful whether you're adding the 2 or whether you're subtracting the 2. So let's add the 2 expressions. So 0 minus 3 is -3. You agree? Good. Let's just choose a different color here. Plus 5 minus 5, plus 7 minus 7, plus 9 minus 9. And everything in between will cancel itself out. Yes or no? What are we left with at the back? Plus 10,001, plus 10,003, Mr. Mudal. There we go. So now what is our answer? This is equal to, let's add that, plus that, plus that. We get 20,001. And that, my dear friends, is our final answer. This is a higher order sigma question where you need to expand. Please, you need to know your number of terms is, how do you calculate number of terms? Your top number minus your bottom number plus 1. Okay. Just to give you another example in this. So, guys, I hope you guys loving the show. I hope you guys are loving the type of questions that we are doing. Remember, all these are exam type questions. We cannot do every humanly possible question in the little time that we have. But hopefully with the type of questions that we are doing, and you master it and you can do it on your own, will equip you enough to be prepared for Friday and for Monday's session. And inshallah, everybody's going to get their distinction. Destination distinction. Right. Welcome everybody to all the different schools. Okay, let's go. Is there a question there? No.
Yes,
Let's go.
I have a question.
Yes.
I have a question.
Sure.
What time are we going to have break, Mr. Khota? I don't know if you can see our program.
Look, I can stick to time. We can stick to the time breaks because
Okay.
maybe, like I said, the some schools have arranged feeding programs and whatever, and so I don't want to go. So we'll stick to the break between 10:30. I'll change the topics as we go along. So just stay with me.
No problem.
But we will complete as much as we can. However, the break times and end times, I'm going to try and go till 3 o'clock today, guys. I'm going to try and go. So please make sure that you make your transport arrangements for 3 p.m. and not 2:30 p.m. Right? I'd like to spend as much time, contact time, in this big 250,000 member family that I've now just acquired yesterday. Right? So well done to all of you. Let's go back to this. I'm going to clear this. There's something I want to show you. Watch this question. Watch this question. I tell you 3 over 2 plus 6 over 4 plus 9 over 8 plus 12 over 16 plus ... Question number 1, extend by 2 terms if the pattern continues. And question number 2, write the above in sigma notation. We're going to do one more after this, and we are done with sigma notation. So firstly, how to expand sigma, right? We did the previous one, how to expand sigma, and this one I'm just showing you how to rewrite, how to go back into sigma notation. Let's see. 250,000, maybe we might hit the 300,000, 400,000 learner mark. Let's see if the whole of South Africa is all activated.
Question.
Okay, and thank you all for activating with Kway and with Okaf. The SN form, are we going to do? Of course, we're going to do the SN formula. We're going to do that. No, we don't use the SN in here. We're going to need the SN formula in the next question. You don't use SN formula when you're writing in sigma notation. Only if, now listen, if sigma is given and you need to calculate sigma, then you use your SN formula. Not in a question like this, where they want you to write in sigma notation. No. So in this case, it won't, but a good question though. And I hope that clarifies. If sigma is given, you use SN at the end after expanding. So in this question, we're not using sigma. No. We're not using SN, sorry. So let's answer question number 1. Now, I know many of you were battling. It's not arithmetic. It's not geometric. And it is not quadratic. So what is it? The numerator is arithmetic. The denominator is geometric. So obviously 3 plus 3 is 6 plus 3 is 9 plus 3 is 12. Your next term would be, it's got a common difference of 3. So this would be 15. Right? Extend by 1 term. So just put the next term, right? 2 times 4, 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. If you wanted to extend by another term, you could add 3 on the top. That would be 18 over 64. There we go. And that's only 2 marks. Now write in sigma notation. Right? Now listen. Listen. They can try and confuse you. You know where's the trap? Guess where's the trap? Where they say to k number of terms. Or to n number of terms. Listen, do me a favor. The trick is to n number of terms. To n number of terms. Now they're telling us that this year is not infinite. They're telling us that it's finite, that my last term is what? N. So what you do, answer to question number 1 is 15 over 32 and 18 over 64. The second question is we put sigma, there's sigma, n number of terms, your number of terms come on top. So be careful, use another alphabet. And what's my name? K. And put K. Use the alphabet K. You know why? Not because of my surname, because it's called the universal constant. No, constant in Dutch. Right. It's the universal constant. Don't think I don't know English, pra. I specialized in English. Right. The universal constant, K. So what we're going to do now, our numerator, now do this on the side. Your numerator is arithmetic. So Tn, but we're not using T, right. So Tk is equal to A plus K minus 1 times D. So Tk is equal to A, which is how much? 3 plus K minus 1. What's your common difference? Also 3. So Tk is equal to 3 plus 3k minus 3. Tk equals 3k. Yes or no? So we go here on the top, our numerator here. You can put it, you can say 3k. If you want to, you can put brackets. They just want your general formula. Remember here, next to sigma, what do you have to put? Your general formula. So you're not using Sn. You're using Tn. Because you want the general formula. Here you're not finding the sum. Now let's do, so N here stood for numerator. Numerator is arithmetic. Now let's go denominator. Denominator, what is denominator? Geometric, yes or no? And we know Tk is equal to AR to the power K minus 1, not N now, because N was your number of terms. The catch here was N that we had to put on the top. Normally N would be at the bottom. So now Tk equals, what's A? What's your first term in geometric? 2. What's your common ratio? 4 divided by 2 or 8 divided by 4 or 16 divided by 8 is how much? 2 to the power K minus 1. So now you got 2 into 2 to the power K minus 1. Sorry, that bracket should come out there. So let's just do this. Let's write this properly. No, we can't. 2 into K minus 1. So we can just leave it like that in the exam. But we can't multiply this 2 inside. We can't multiply this 2 inside. Why? Because the power belongs to the base, not to the coefficient. If you wanted to, let's see if we had 2 into 2 to the power K. 2 to the power K times 2 to the minus 1. Am I right? If we broke this up. So that's 2 into 2k into a half. And that can cancel out. So you just, sorry, this is to the power. That's to the power. So it's 2 to the power k. 2 to the power k. 2 to the power k. Look, I don't know. I think at this point here, they would give you the marks. At sometimes in your memo, they could stop. They would stop here. They'll say if you put it there, they'll give you the marks. If you brought it even further down to that. So say you had 3k over 2 to the power k, that would also be correct. That would also be correct. Okay, we got one last one now. The smallest integer value of k. You've heard of those ones that come out in your exam. Determine the smallest integer value of k for which. So now we're going to do one more, and we're wrapping up our sequences, our series. All right. But here I'm going to ask you now, find this. Firstly, you got to find k, and then you got to find the sum of the first 10 terms. All right, so let's go. So here we're going to be using it, guys. Okay. And then find the sum of the series. So let's go. Let's erase here. Let's erase. I hope you've all taken it down. So remember, guys, just to recap here, that was your numerator. That was your denominator. There's your numerator. There's your denominator. General formula for numerator. General formula for denominator. And there we go. There's your calculations. Okay. You've taken it down. You've taken it down. Find the smallest value of k. So take this, find, here's your next question in your exam. Find the smallest integer value. The smallest integer value of k for which then they give you sigma, they give you k, they tell you p equal 1, they tell you 2 to the power p minus 4 is greater than 30. Where 2 to the power p minus 4 greater than 30 for 5 marks. Right? And I hope that with this variety of questions, this bouquet, let's use proper English, the Queen's English. Well, this bouquet of questions, oh, super mark, wallah mark. With this bouquet of questions, that it should give you enough tools for you to be able to be ready for next week, Friday's paper. Amen. Right. So the first thing, you know what you need to do? Here you need to expand. Here you need to expand. And here you need to calculate sigma. Now we come back to that question that girl asked earlier. When do we use the SN formula? This is where you're going, because sigma is given. Now you expand and sigma means SN. So let's start. Again, what's the first thing we do? We determine if there's a letter on the top or a number on the top to determine whether it is finite or infinite. P equals 1. Guys, sometimes they can trick you. They can call this here -1. So yes, you'll put in -1 first, but your next number will be 0, not -2. I see some learners go descending order. No, when you substitute, you always substitute ascending from lowest to highest. So 1, 2, 3, 4, not 1, 0, -1, -2. So let's go. 2 to the power 1 minus 4 plus 2 to the power 2 minus 4 plus 2 to the power 3 minus 4 plus 2 to the power 4 minus 4. I just did the first 3 or 4 plus ... to be greater than 30. Now remember, because it is finite, the last term will be 2 to the power what? K minus 4. Remember, we have to put in K there. I put in the last term here. I put in the last term for the mere reason to show you that this is not infinite. Yeah, it's geometric. So let's go. So that's 2 to the power minus 3 plus 2 to the power minus 2 plus 2 to the minus 1 plus 2 to the 0 plus dot 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 2 to the power k minus p. 4. What am I doing? K minus 4. Hey, you know what? It's not k minus 4. Your last term is 2 to the power k. It's k on its own. The last term is k on its own. Your last term, listen to me. Correct. Greater than 30. Your last term is 2 to the power k. You're taking the whole. P minus 4 represents k. No, k minus 1 plus. Yes, your number of terms. Guys, your number of terms. Your number of terms here is going to be k minus 1 plus 1. Your number of terms is equal to k. Right? Yes, maybe you can say that your last term is going to be k minus 4, but we're not interested. We're not interested in our last term in our SN formula for finite. Finite geometric. What did I say? This is finite geometric. So 2 to the minus 3 is 1 over 8, plus 2 to the minus 2 is 1 over 4, plus 1 over 2, plus 1. It's immaterial, it's finite, greater than 30. Right. So A is equal to 1 over 8. Your R is equal to this divided by that, which is how much? 2. And R is greater than 1. So finite. So now you have to use your SN formula. Right? So Sn is equal to, where R is greater than 1, we go A into R to the power n minus 1 over R minus 1 greater than 30. So 1 over 8, that's A, into, what's R? 2. What's N? What's N, your number of terms? K minus 1. All over, what's R? 2 minus 1 greater than 30. Let's work this out. So 2 minus 1 is 1 times 8 times 8. So I'm just moving over to the side. 2 to the power k minus 1 greater than 8 3s are 24, 240. 2 to the power k greater than 241. My good friend Mr. Logs come into play again. K log 2. If I attach a log and I bring the k to the front, I get k log 2 greater than log 241. K greater than log 241 divided by log 2. K greater than 7,912. So therefore K is equal to, K is an integer, the smallest integer value. So what's your first integer greater than 7,9? 8. Greater than. Your smallest integer value greater than 7,9 is 8. That's your first integer greater than 7,9, which is 8. Yes, the minute they say integer, very good. The minute they say integer, no decimal. You know what are integers? Minus 3, minus 2, minus 1, 0, 1, 2. So it's all your positive numbers, all your negative numbers, no decimals, no fractions. Right? And there we go. That brings us to the end of our sequences and series. Onliners, schools, hit us up in your comment section. Let us know Are you guys enjoying? Yes, always logs. We had to use logs there. We had to use logs. Where's the 240? Oh, okay. The 240. Remember this 1 over 8. How do I get rid of 1 over 8? I multiply that by 8 over 1. What I do on the left, I do on the right. So that and that cancels out. 8 times 30 is 240. I hope that answers your question. Guys, we are a couple of days away from our exams. You need to be sharp now. You need to be sharp than the sharpest pencil. Please, I know some of you, your pencils that you are writing with are smaller than my small finger. Wallah, I'm not lying. I've seen this. I've seen this. Your pencils are shorter than my small finger. They are not even sharp. They are as blunt. Gosh, how are you going to expect? Please, when you go and write your final exams, go and write it with a sharp pencil and take a sharpener with you. Right? Be sharp. Okay, guys, let's go. Right, I'm clearing here. I'm clearing the frame. Right, there's something I want to talk to you. Guys, let's just talk a little bit about our analytics. Let's talk quickly about analytics, right? So I want you to do, we're going to go into trigs, but there's something I want to teach. I'm not going to go into analytics and circle analytics in detail. I'm just going to touch on the concepts required for you for next week, Friday. If you can understand these concepts, you'll be okay. Because you've been doing analytics and circle analytics from grade 10. Right? Grade 10, grade 11. The main thing, the angle of inclination. And the equation of a circle whose center is not at the origin. And the equation of a tangent. You need to know that. If you don't know that, you can't play around in analytics. So let's just do a quick analytics model. Come, let's take one down. Take this one down with me. Right. Let's do this. Let's do that. I'm now doing analytics and circle analytics. And what I'm going to do now, let's see. Let's draw a circle here. Whoa, that's a terrible circle. But in any case, let's draw a circle. Let's give you a point. I tell you P is the center of the circle. It's 2 and 1. It's 2 and 1. I'm now going to give you a line going from there to here. I'm going to call this point R. And that is 0. That's your y-axis. This is your x-axis. This point here is 0. 0 on my x, minus 6 on my y. Take that one down. P is the center. P is the center. Right. I'm going to give you, watch this. Let's just draw it out here. I'm going to give you a point here. PQRS. Let's call that point S. And let's draw a line going past there. There we go. We got a tangent passing there. And then I'm going to take a line and I'm going to put it there. There we go. PQRS. I'm going to tell you that this here on the top is angle theta. And now we're going to ask you a variety of questions on this. If you can play around and you can understand this, you'll be able to do everything in your exam. Okay, I'm going to show you all the tools required based on this one diagram. Right. Then I'm going to give you a point here. And I'm going to tell you that is minus 10 and y. Right. Here goes your questions. Let's give you an exam model. Let's build up. Guys, I've made this one up. I've made it up here, but it's strategically made up for you now. For one reason, I can ask you all the questions in analytics based on this one diagram. So every tool that is required for you to know. Remember, you're going to get 2 analytics questions in your paper. Let's talk about paper 2. After you've taken down this, let's talk about paper 2. Paper 2, you know your data handling, 20 marks. And that's easy. That we're not even going to touch today. Mean, median, mode, Ogive curve, standard deviation, variance. 1 standard deviation away from the mean. Right? I'll show you a higher order question on data handling just now. Right? I'll show you a higher order question when we're done. So data handling, 20 marks. That's easy. Analytics is 40 marks. 2 questions on analytics. So 2 by analytics. 1 normal analytics, 1 analytics combined with circle analytics. So it's 2 by 20 marks. Then you got your trigs. Right, so what do we have here? 2 times 20 is 40. 40 plus 20 is 60. 60 plus 40 is 100. And then our friend, Mr. Euclidean. And 50. Right, so sometimes it could be 50 and 40. 50 trigs. 50, but that would include your trig graphs. 50 trigs and then 40 Euclidean. But your Euclidean, again, I always tell you, don't stress about Euclidean. Your grade 11, circle analytics, proving all your easy stuff from grade 11 and your easy grade 12 will at least be, out of this 40 marks, would be at least 25 to 30 marks. Right? Let's say 30 marks. Only 10 marks will be your heavy, will be your difficult, will be your higher order. Don't panic. I know you guys all panic. Don't worry. You can get your full, you can get 30 plus, you can get full marks everywhere. This you leave for last. You can still get 140 out of 150 for your paper. But we're going to tackle it. But don't panic. Don't panic. Okay. So that's just your overview for paper 2. Let's just go back. Let's start with the questions on this. Come, I give you a series of questions, right? Come, I give you, because I don't want to do the work for you. All 250,000 learners now in this country, let's see whether you can answer these questions. You are going to score yourself now. You're going to do it quickly. You're going to do it quickly. And you are going to see out of 20 or 30 marks, 20 marks, how much are you going to score? So here's a little test, a quick in-house test for you. Question number 1. Question number 1. I want the equation of the circle with center P. Equation of circle with center P for 4 marks. Question number 2. I want the equation of the tangent at R. For another 4 marks. I want find angle theta for 5 marks. Question number 4. Another circle. Here's your higher order question, the last one. Another circle with center -6 and 8 and radius of 10 is drawn. Do the 2 circles. Do the 2 circles touch each other? Have 2 distinct points of intersection? Or no points of intersection? Show all calculations without drawing. No drawing. Show all calculations. Huh? No. You're gonna get marks because it's worth 4 marks. It's worth 4 marks. No drawing. Show all calculations. Show all calculations for another 4 marks. So let's see. 4, 8, 12, and 5, 17 marks. There's a little test for you, a little in-house test for you for today. This is easy work. That is why I'm not doing it for you. I'm going to do the memo with you. We're going to do it together. Let's see how well you do. This here is not A plus R. This is at. Somebody will say, was that A plus R? Mr. Khota, your handwriting, boss. So question number 1, let me just quickly go through the questions with you. The equation of the circle with center P, the equation of the tangent at point R, find angle theta, another circle with center -6 and 8 and radius of 10 is drawn. Do the two circles touch each other, have two distinct points of intersection, or have no points of intersection? Show all calculations. 17 marks.
6 in Mr. Khota.
Just says, man, here I get paid to talk. Because I give myself a headache, you know that.
Yeah, man. Too much snoop.
People ask
man,
me, do you actually love to hear the sound of your own voice? I said, no, really. My brain spin, man. You know, sometimes I'm so tired after I do a workshop and we do so much of math, I think I'm going to sleep. Then I go and sleep. And then I dream I'm in a workshop. Then I wake up and it's like I've never slept, bruh.
Sure. Lay off that karate juice, Mr. K.
Hey, the karate juice. Come, guys. Come, guys. Here's a test. 17 marks. 17 marks. 17 marks. Let's see where you guys at. Have fun, have fun, have fun. Have fun, have fun, have fun. We're going to do this model. Maybe this model should take us till break, and then probably we'll start with trigs immediately after break. Or if we have enough time before break, I'll kick off with trigs before break. Right. So the equation of the circle with center P. How far are you guys? How many more minutes do you need? 5 more minutes? All right. They've asked for 5 more minutes. Hassanain, I'm going to take a quick bathroom break.
Come back, Mr. K. We
Yes,
need you,
I'll be
eh?
back. I'll be back. I'll be back. Come, we're going to mark this. I want you to score yourself.
Okay, you are relieved. You can go.
Yes.
Number 1, number 2.
Quick bathroom break.
Number 1.
17 marks. 5 minutes.
Okay. Okay.
Thank you. Work it out on your own. So far, so good, sir.
Yeah.
Everything okay? You need anything? No. You sure? The only time you'll use decimals, I think, is for the last one. The only time you will use decimals, I think, is for the last one. We are back. We are back.
Mr.
Call of
Khota.
Duty. Yes, sir. Yeah. So put it off. Yeah, but I'm dying in here. It's hot. It's hot.
Welcome
It's
back.
getting
Welcome
hot
back.
in here.
Welcome back, Mr. Khota.
It's getting
Welcome
hot
back.
in here.
Mr. Khota, I want to show you a video quickly. Maybe you can.
Yeah. To his tomb just to say
Mr. Khota,
salute, boss. Yes.
What is happening there? That is true power there. That is like a majestic moment. Please give us some context and fill us in there, brother. That is really something.
No. That was amazing. That workshop, that weekend with the Department of Education, KZN. We spent about 4 days in Mandeni. It was absolutely electric. Really good. Good vibes at Kway. We've done lots of, just to give you guys, I know you guys are still busy working. These guys are so excited here. They're all fighting with each other here in-house to get the full 17 marks. But I'll tell you, we got committed learners here. But in any case, Hassanin, guys. Okay. So yeah, we've done, I just want to give big shout out Mitchell's Plain, because I've done lots of work in Mitchell's Plain, Spine Road High, Cedar High, Lentech here. We've also done a lot of work in Kailicha, Dr. Harry Gwala, Maniano, Luhlaza. I'm just trying to think, Luhlaza, Maniano, CPUT, Cape Peninsula University of Technology. We also did COSAT in Kailicha. We also did Grasmere. We did Shoshanguve. We did Bronkhorstspruit. We did in Soweto, Jabulani. We did PACE, Jabulani Tech, Taba Jabula. Do you guys remember? We did Ennerdale. We did RW Fick. That was the whole Coronation area. So yeah, all in the house. Big shout out to all of you, all your schools. This is what we've been doing over the past 20 years. Alhamdulillah, we are now celebrating 20 years. You see all the white hair. I started when all this hair was black, and the hair was on my head, not on my face. We're 20 years in the game, guys. 20 years. So alhamdulillah.
Okay, Mr. Khota,
Let's
it's
start.
yours. Take it away.
Let's go. Okay, now I don't remember the questions. I made them up as we went along. You now have to give me the questions. I'm going to erase all of this. I'm working out the memo, guys. Right, so you guys took down all the questions, correct? Right, so let's do this. Let's erase all of this. Let's erase all of this. And let's get cracking, and let's see whether you guys got 17 out of 17. Your full marks for this. Guys, if any of these questions you don't know, you are in trouble for the Tuesday's paper. But like I said, don't stress. No, Monday. Sorry. I don't even know. Following Monday. Yeah, you write the following Monday. But in any case, don't stress. Next week, Saturday, as you guys all know. And thank you for all the inquiries yesterday that came on WhatsApp about Saturday's workshop. Remember, next week Thursday, next week Saturday, another Kway workshop. So let's get started. The equation of our center P. Right, so now we know x. The first thing we need to know is we need the radius. I don't have the radius, so we need to find PR. So PR, in fact, what I'm going to do, PR squared, which is R squared. Distance formula, you need to know x2 minus x1 all squared plus y2 minus y1 all squared. So R squared is equal to 2 minus 0 squared. I'm using this, right? That's x2. I'm using this as x2, y2, just for this example. So 2 minus 0 squared plus 1 minus 6. 1 plus 6 squared. So R squared is equal to, what is that? 2 squared is 4 plus 1 plus 6 is 7. 7 squared is 49. So R squared is equal to 53. Right? So I'm just putting it in brackets. So R will equal to the square root of 53. Now the equation of your circle, EQTN. I'm just using your WhatsApp language, right? The equation of your circle is x minus x1 squared plus y minus y1 squared is equal to R squared. Guys, by now, if you really want to be a boss in math, learn your formula. Learn all your formulas so you don't need to refer to your formula sheet. Please know it. Even with your compound and double angles, I'm going to show you how to remember it when we do it, and then we're going to crack all our, so how to break up your compound angles, how to break, remember, know your formula by memory. So now, x, what does x1, y1 refer to? The center of your circle. So that's no longer x2, y2. So x minus 2 squared plus y minus 1 squared. We have to use the center of our circle because we want the equation. Y minus 1 squared is equal to R squared. What is R squared? 53. Not root 53. 53. Many of you ask, why did I say PR squared? Why didn't I say PR equal the square root? It's the same thing. It's the same thing, but I wanted R squared. So you square the one side, you square the other side. Okay. Now that was the equation of the circle. We found the distance. We found the distance. And then we found the equation. And that was your first 4 marks. I hope you all got that right. What was the next question? The equation of the tangent. Very good. The equation of the tangent. So now, the equation of a tangent is given by what? Y is equal to mx plus c. Good. So what do I need? I need the gradient and I need a point. I got a point. Listen. Question number 2. Let's do question number 2 together. We need the equation of a tangent. So a tangent is y is equal to mx plus c. So what do I need? I need a point and I need a gradient on your straight line. So on your straight line, that's your tangent. So I got a point. Do I have the gradient? No. Can I find the gradient? Yes. So we know from Euclidean that a tangent or radius is always perpendicular to, so I'm going to give you a template now, guys. Learn this template. Learn this template for your exam. So the first thing we're going to do, we're going to say m of radius, m rad. M of radius, y2 minus y1, y2 minus y1 over x2 minus x1. So 1 plus 6 is 7 over 2. Therefore, the m of your tangent will equal to minus 2 over 7. Why? Because it's perpendicular. It's 90 degrees, right? Because your radius is 90 degrees to your tangent. So the shortcut of doing it is you change the sign and flip the fraction, because your m of your one line multiplied by the m of your other line must equal to minus 1. So the shortcut, change the sign, flip the fraction. For parallel lines, your gradients will be equal. For perpendicular lines, the product must equal to -1. And the shortcut, change the sign, flip the fraction. Change the sign, flip the fraction. Write it down. Change the sign, flip the fraction. Now we got the gradient. There we go. And we got a point. There we go. So boom. Now watch. Therefore, your equation EQTN of your tangent. Let's do it. So this was step number 1. That was step number 2. This is step number 3. You do it in exactly the same order. You change nothing. I am not doing rough calculation. I'm doing it exactly the way you will answer it in your paper. And it makes logical sense. Now, equation of your tangent. Y minus y1 equals m into x minus x1. So now we have to use y plus 6 minus 6 is plus 6 is equal to m, the new m that you found, minus 2 over 7 into x minus 0. So y plus 6 is equal to minus 2 over 7. X minus 0 is x. And here's your final answer. Y equals minus 2 over 7x plus 6 will come on the other side as minus 6. Yes. No, it's fine. Yes, you must show y is equal to mx plus c. Right. But you know this graph here goes through minus 6. Yes, you could have done the shortcut and just because we know. But we've done all of this so that at the end we don't think we're right. We know we're right. What do? We know we're right. Every time you are done in a question, ask yourself, do I think I'm right or do I know I'm right? You must be absolutely convinced that the answer you got, and there are checks and balances you can put into place. Obviously, that's your y-intercept, and the graph goes to y minus 6. So there's a check and balance. You got thumbs up. Right? What's your next question, guys? What's our next question in the test? The nice one. Find angle theta. Now, there are many ways that you people do this. Hassanain, we there, bro? Hassanain. Where's my friend Hassanain? Hassanain, are we good there, bro? All right. Onliners, how are we doing? Are we all okay? Hassanain, you there? Yeah, Hassanain disappeared, bruh. I think Hassanain fell off toilet break. Hassanain. Psst, psst. Hello. Right, guys, let's go. Let's wait for Hassanain. We don't know where. He went for a coffee break. How much time do we have? Okay, we're still on time. Right, we're now finding angle theta. Right. Now, what did we find? This was question number 3. Am I right? So, and what did we find our equation of this line was? Y was equal to minus 2 over 7x minus 6. Am I right? Right. The first thing I need to do is I need to find S's coordinates. So S's coordinates, we got the x. So y equals minus 2 over 7. X is minus 10 minus 6. What does that give me? Calculator? Minus 22 over 7. So minus 2 over 7, x is minus 10. So let's go. Minus 2 over 7. What is x? Minus 10, close brackets, minus 6. Again, minus 20, minus 3,14. That means S had to actually be below. This is not drawn to scale, right? Was this equation correct? Yes, sir. Right.
Mr.
Yeah, yeah,
Khota,
yeah,
were
yeah.
you looking for me, Mr. Khota?
Yeah. We were screaming for you, Hassanin. We don't know
I
where
can
you
see
went.
in the comments. Now I'm back, I also
Oh, you
had to
back.
go
You
for,
back. You back. You
I
back.
had
You
to
back. You back.
replenish my food and whatever nutrition, yes, I don't
Okay,
die on
let's
the
just
job.
do something. This one here goes, if I made this minus 20, let me just check. Minus 2 times minus 20 divided by 7 minus 6. Do I get a positive? I still get minus 2 over 7. Right. Okay. And if I do, let's make this value smaller. Let's make it minus 4. Right. Minus 2 over 7 minus 2 over 7 into, I'm playing around with these values just so that I can get a positive value. I get minus 34. All of them I'm getting a negative. Okay, never mind. It's fine. Let's just write it out. So what do we get? What is our y value here? Minus 22 over 7, right? You sure this was minus 2 over 7, not minus 7 over 2? Yeah, my diagram is incorrect. Okay, it's fine. It's minus 22 over 7, minus 22 over 7. Okay, now watch. Now watch. We want angle theta. Now angle theta hangs here in the air. So what you can do, remember that's not against your x-axis. I'm going to teach you a little trick. I'm going to teach you guys a little trick. So we draw another false x-axis there. Watch here. Watch here. I extend this line going up there, and I extend that line going there. Right. You know why I do that? Because whenever you calculate your angle of inclination, it's your x from your x-axis up. So what we're going to do, we need this theta is equal to that theta, which is vertically opposite. So what I'm going to do, I'm going to calculate big angle. I'm going to call that theta 1. Small angle here, I'm going to call that theta 2. And theta, angle theta is going to equal to big angle minus small angle. So what you do at that point, listen to me. Step number 1, draw a false x-axis at that point, which is parallel to your x-axis. Extend your two lines, big angle minus small angle. So now watch, big angle. So let's say theta 1. Tan of angle theta 1 is equal to the m of which line? S. Theta 1 is this big angle here, SP. Yes, you're right, SP or PS. So tan theta 1 is equal to, what is the gradient of this line? We don't have it. y2 minus y1 over x2 minus x1. So theta 1 will equal to, let's do it on our calculators, shift 10 fraction. You got minus 22 over 7 minus 1 over minus 12. Minus 10 minus 2 is minus 12. Close brackets equals. I get 19,04, but 19,04 is an acute answer. It's less than 90, but theta 1, the big angle here, is obtuse. How do I get an acute from an obtuse or obtuse from an acute? 180 minus, because angles on a straight line add up to 180. So therefore, the big angle, angle theta 1, is 180 minus 19,04. And 180 minus 19,04, 160,95. There we go. That's theta 1. Guys, I'm just showing you. Let's do it in red. That's angle theta 1, that big angle there. Theta 1. And that's because it's the straight line. The same gradient at the bottom is the same gradient on the top. It's a straight line. The gradient is the same throughout the line. 160,96. You can make it 161, but you know what? Let's try and keep it to 2 decimal places just so we can get as accurate as possible. Now let's do theta 2. Tan of angle theta 2. Remember, here's theta 2. Here's theta 2. Hassanin, you there? tan of angle theta 2 is equal to the m of which line? Where's Hassanin?
I'm
Disappeared.
munching on chips, Mr.
Oh, you
Khota.
I actually even heard you frying the chips in the background, you and your whole family.
No, man. Samosas tomorrow, not today.
Samosas.
No samosas
No.
today.
Yeah. Yeah. 160,96.
No, 96 years. So that when you add it with 4, 04 up there. 19.04.
Yeah. Oh, okay. 180 minus 19,04. 180 minus 19,04. Yes. Okay, 160,96. 160,96. All right. Thank you, sir. All right. Now, tan of angle theta 2 is equal to the m of which line? Theta 2 touches SR. Didn't we find SR? There's it. There's the gradient. So tan of angle theta 2 is equal to minus 2 over 7. So theta 2 is equal to shift. Remember, angle of inclination always tan. So shift tan minus 2 over 7. Minus 2 over 7, boom. I get minus 15,95. Minus 15,94. Minus 15. Yeah, 94595. So what do? Must we round it off to 2 decimal places? Minus 15,95. But you know why I wanted to use a 4? Because a 4 and a 6 would have worked it out. Okay, anyway, minus 15,95. But theta 2 is also obtuse. So therefore, theta 2 is equal to 180 minus 15,95. Right? Or you can say plus 180. I get 164,05. 164,05. Now, some of you might ask me, why don't I say 180 minus minus? No, you can't say minus. This here only tells you the direction. That negative only gives you the direction of your angle of inclination. You're using 180 minus. Why? Because adjacent supplementary angles on a straight line add up to 180 degrees. So theta is equal to theta 1 minus theta 2. 1. And yeah, okay, yeah, in this case here, we're going to get a negative because this thing here wasn't drawn to scale. Right? Your big angle, this was supposed to be your big angle minus your small angle. You get 160,96 minus 164,05. In this case, we're getting a negative minus 3,09. Okay, if you did get this answer, you would be correct. Listen to me. Normally, you wouldn't be getting a negative because your bigger angle minus your smaller angle. In this case, guys, because this triangle wasn't drawn to scale. Yeah, possibly. So you got 3,09 degrees. 3,09 degrees. And that would have been, even if you drew it the other way, you would have got the positive. Now you're getting the negative. The negative is just showing you the direction of the angle. Okay. Right. We're almost there. There's 2 minutes. No lies. There's 2 minutes. What's the next question? Your time is all wrong. No, what's the next question? Isn't there only one question left?
Yeah.
Right. There's one question left. Now, guys, I want you to take this formula down if you don't know how to do the last one. If you don't know how to do the last one by calculation. So in this one, we drew a false x-axis. Big angle minus small angle is this angle in between. And these two angles are vertically opposite. We're almost there for break, guys. We're almost there. I want you to take this formula down. Whenever they're asking you about where the two circles have two distinct points, no distinct points, or no points, or whether they touch each other, whether the two circles just touch. Right. Take this. The answer to question number 4. Right. If your distance between your centers if your distance between the two centers is greater than the sum of your radii. Right? Let me write that neater. We're almost there. I just want to take this formula. I want you guys to learn this. I want you to learn this. This is so important. I'm telling you, you're getting tested on this. I don't know, Mr. Mudawi is here, but my heart tells me that I'm almost 99.9% sure you're going to be tested on this. So the distance, you'll thank me later. The distance between the centers, if it's greater than the sum of your radii, the sum of the distance of the length of your radii, then they will have no points of intersection. That means the two circles will look like this. You got one circle here and you got one circle there, and the distance between the centers is greater than the sum of your radii. So they'll have no points of intersection. And if your distance between your centers is less than your sum of your radii, they will have two distinct points of intersection. Meaning the two circles will look like that. They will overlap. And if your distance between your centers is equal to the sum of your radii, then the two circles will just touch each other. The two circles will just touch. And another, they will touch externally at one point. At one point. And another word for that, another word is called tangential. The two circles are just tangential. They touch at one point. They touch at one common point. Learn this. I beg you, learn. Please. Kanalla.
Kanalla Butabala.
Kanalla Butadullah. Dolce and Khamaiti.
Ay.
Okay, Buta. End of the first session. No shukran.
Mr.
Right.
Khota, I'm convinced you are beaming from Cape Town. You
No.
from Athlone 7764. You're beaming
Straight
live
from the Auckland Park. Straight from the Auckland Park. Boys and girls, ladies and gentlemen, Jazakallah so much. Thanks for all tuning into our great bumper show. After break, we are cracking trigs. After break, we are cracking trigs. You want to be here at 11 o'clock. Break till 11 o'clock. Enjoy your guys' comfort break. I'll see you guys back after the session at 11 p.m. Lots of fun today. Lots of fun. Enjoy the session. Assalamu alaikum. Yeah, we'll calculate it after break. You guys will do the calculation, not me. Here's it. So what does it do? Ready on your phone. Let's go again. In 3, 2, 1. Essay!
Plus 6 divided by 2. 2 plus 6 is 8. 8 divided by 2. Number
Mr. Khota, you're going to have to unmute on your side.
It's time to rock and roll.
Yes, reload that thing. Put some bullets in the chamber. Fight
There we
away,
go.
Mr.
There we go.
Khota.
There we go. Call of duty. Call of duty, bruh.
Yes, no, you're
Time
looking
to
like
rock
a
and-
silent
this is duty
assassin
calls.
there. Yes.
Duty calls, duty calls, duty calls. Let's go, let's go, let's go. And we are all back. We all back, ready and waiting. We back. Yes, Samuel Nkomo. Right. Let's go. Double animations. Ready and waiting, Mr. Julius and Katlejo and Kosi. We're ready, Mr. K. Let's go. Okay, so we got this one. Listen, just give me the values. So the answer to the last one, wait, just give me. So what was the, let's answer the last one. I'm not going to do all the calculations. You guys will just check whether you are right? So what was the distance between the centers? You use the distance formula. Come, guys. I'm just erasing all of this. We found out exactly where I went wrong here. Guys, I'm just going to redo this last part here quickly. So the distance between the centers, and all thanks to Isa. Isa came up and said, Mr. K, can't we? And I found out exactly where we went wrong here and why this thing worked out to a negative. So I know many of you worked it out during break and you said, couldn't you work it out in a different way? Yes, there is a different way to do it, a better way. I think I was wrong here, right? So I will admit. So let's go back to this one here. What was the distance between your centers? Square root of 113, which was equal to 10,03. And then what was the sum of your radii? Was 10 plus root 53, which was how much? 17,28. So what can we say here? The distance between the centers, was less than the sum of your radii. Yeah, the distance between your centers was 10,03, is less than the sum of your radii, which is 17,28. Therefore, we can conclude they will have two distinct points. And that's the answer for that. Okay, the answer that I gave you in the previous one for question number 3, I'll tell you where we went. This system works, but not for a 90-degree triangle. So let me just erase everything. I'll show you exactly where this system works. The system will work for a non-90-degree triangle. In a 90-degree triangle, we had this as minus 10. Let me just put this point here, S. S worked out to negative 10 and minus, what was it? Minus 22/7. Okay. Now, the way Isa did it, I'm going back to question number 3 quickly. And this was a nice way of doing it. Was actually the correct way of doing it. Because it's a 90-degree triangle. We're going back to question number 3. The radius here, the radius was root 53. Right. The distance, what is the distance? We can calculate the length of the hypotenuse. Isa, what was the distance between these two? S and P. 11,82. So he calculated the distance between S and P. So SP was equal to 11,82. The radius R was equal to root 53. And the way Isa did it, which congratulations, which is the correct way, because it's a 90-degree triangle. Just to show you here again what it looks like. It looks like that. There's your triangle. I just cut it out. That's root 53. That's 11,82. It's a 90-degree triangle. So obviously you can just use SOHCAHTOA from trigs. You can say sine theta. right? We can use sine theta is opposite over hypotenuse, which is root 53 over 11,82. So theta will equal to, let's go, shift sine fraction root 53 over root 53, wait, come on, root 53 over 11,82. And what do we get? 38,01. And that is correct. 38,01 degrees. So guys, just go back to that one. Go back to question number 3. So you might ask, so then where does your system, Mr. K, work? My system would work like this. Obviously, for if I had a triangle that looked like this, let's say it went like this, it went like that, and it went like this, and let's say this was a non-90 degree triangle. This was a non-90 degree triangle. Then, yes, the system, if theta was there on the top, I can make a false x-axis there. I can extend this line going there. I can extend this line going there. Then obviously, big angle, I can call that theta 1. Small angle there, I can call that theta 2. Big angle minus small angle will give me that angle. And that angle are vertically opposite. So for a non-90 degree triangle, you can draw your false x-axis. For a 90 degree triangle, we just use SOHCAHTOA. Okay, so there's the correction for that last one. So I hope you guys all got it right. I think it puts it all into perspective. I was figuring it out. Why am I getting negative 3,08? It didn't come to me. Okay, so now, thanks, Isa. Always good having good top students here with us in-house. And that brings us to the end here. Guys, I hope you guys are enjoying today's session. Let's go into trigs. Now, remember, sine of a compound angle, please, you need to know your formula. Right? Remember what we're going to do. If you've missed any of our basics, you have to go back to the previous Okaf session, which is on the Okaf website. Remember, today is application. So if you don't know your rules and you don't know basic to intermediate, you still need to refer to the previous Okaf program on the Okaf website. We're going into application now. We're starting with trigonometry. Where's my pen? Why did it disappear here? Oh my word. Come on, Mr. Pen. What's happening here? Hey. Whoa. Give me a second, guys. Give me a second.
Use your finger there, Mr. Khota.
Hey, my pen disappeared here, bro. And my cursor disappeared. Okay, I see it. Oh, I've got it on eraser.
Mr. K.
Hey, I'm telling you the pressure in this room, bruh. Pressure. Okay, let's go back. Again, what do we need to know for trigonometry? You need to know your diagrams. They're definitely going to give you a question on diagrams. They're going to give you a question on your compound and double angles. They're going to give you general solution. Shh, guys. Right, general solution. They're going to give you general simplification. And then obviously your trig graphs. And then your non-90, then your trigs, your 2D or your 3D trigs, what they call trigs in 2D. Right? Your area rule, your sine rule, your cos rule, your area rule. Right, let's go. Now let me have a look here. Let's look. I'm going straight to a past paper. I'm going straight. I've got some past papers here. I've even got your prelim paper here. So let's have a look. Let's take these papers out. And this was paper 2. And let's start off here with the first one here. Here we go. So So what did they give us here, guys? For 3 marks. So let's start with the diagram. Now remember, you're going to get this here in this order. In this order, they might just mix up the order, but this is generally the order in which you're going to get your questions under trigonometry. Please, guys, sine, double angle and compound angle. You need to know. You need to know your formula, and let's get started. So let's go. So we start here. Let's start with a diagram. Let's start with one like that. Let's give you this, and they give you a point here. They tell you that's -3 and -3 root 3. That's x, that's y. They call this whole angle here 2 theta. So there's your double angle. This is question number 1, guys. We are starting with trigs. Okay, I'm going to add questions to here. Right? So although they've only given you, because I'm just using this as a model, and then I'm going to teach you everything there is to know about the model. Right. So you're given this diagram, a reflex angle 2 theta without the use of a calculator. Question number 1, they want cos 2 theta. Question number 2, they want sine theta. Right. There we go. Right. So these are, that one there is worth 3 marks, and this one here is worth 3 marks. So these are your questions. Here are your answers. Right. Where do we begin? We drop our 90 degree. We drop our perpendicular. We drop it against our x-axis. We know that's x and that's y. So now the y is -3 root 3. The x value is -3. We need now our hypotenuse. So let's first calculate our hypotenuse. So h squared is equal to -3 squared. I'm using Pythag. You always use Pythagoras to finish your diagram, and then plus -3 root 3 all squared. So h squared is equal to -3 squared is 9 plus -3 squared is 9 times root 3 squared is 3. So h squared is equal to 9 plus 9 times 3 is 27. H squared is equal to 27 plus 9 is 36. H is equal to the square root of 36, which is 6. Very good. So H is equal to 6. Only after you complete your diagram, let's answer cos 2 theta. Cos 2 theta. Cos 2 theta. Now, this whole angle here is 2 theta. So we're working there with 2 theta. So cos 2 theta now is just going to be your adjacent over your hypotenuse. Right? And what is your adjacent over hypotenuse? -3 over 6, which is equal to -1/2. And there we go. We use that as your reference angle there. Watch here. Watch here. In the next question, here we use the entire 2 theta because our angle here, listen to me, because our entire angle here was referred to as 2 theta. That means your reference angle in your triangle is 2 theta. So that's in fact, you could answer this entire thing as question number 1. Right. Let's now go to sine theta. Let's do question number 2. We want sine theta. But your reference angle is 2 theta. So where do we start here, guys? Where do we start? Just move your bag here for me. Right. Watch here. Watch here. Watch here. Watch here. We know that from our previous question, cos 2 theta, watch here, cos 2 theta was equal to -1/2. That was from our previous question. Now, how will I get a sine from a cos? That's your double angle for cos. That's your double angle. So we'll have 1 minus 2 sine squared theta is equal to -1/2. Are you guys following? And all we do now is make sine theta the subject of the formula. So -2 sine squared theta is equal to -1/2 minus 1 is minus 3 over 2. The negative and negative will cancel. Times 1 over 2 times 1 over 2. Sine squared theta is equal to 3 over, get rid of that 2. So divide by 2 or times a half is 4. So therefore sine theta is equal to the square root of the entire thing, which is root 3 over 2. And there's your final answer. This next one, they only gave you 3 marks. Generally, it's up to 5. They could give you up to 5 marks for this. Another example like this, I'm going to choose a higher order question from another paper. This one is your prelim. This is the one that came out in your please learn this. Please, I beg you, learn. That's how we get a sine theta from a cos 2 theta. How's our onliners doing, guys? Are we all on fire? Are we learning? Are we understanding? I'm going to do one more example. I'm going to do one more example in this. Yes, Bronadine. Watch this. Watch this. The second one, okay, to repeat the second one, we needed sine theta, but our reference angle was cos 2 theta. So I'm starting with the first question. Remember the answer to the first question, that cos 2 theta was equal to, cos 2 theta was equal to minus a half. So we start off with that. We start off with cos 2 theta is equal to minus a half. That's a double angle. So I want sine from it. I want sine from a cos. So this is your formula. Cos 2 theta is 1 minus 2 sine squared theta. That's your formula. Then we broke it up. Then we just made sine theta the subject of your formula. Let me do another one like this. Let me do another one like this. Watch. Learn this one. They love this. And we've done this in all our workshops before, even in our previous Awqaf workshop, even in the Kurtuba online. So guys, please learn this. I told you guys it's coming out. And it came out in your prelims. And that's how you guys got your distinction for it. All right. You satisfied. All right. So here goes another one, guys. Watch this. Watch this. Let's give it to you here. Let's give you a point here. I'll call that point R. Let's call that minus 4. And let's call that 10. Right. Question number 1. Oh, right. All right. So there we go, right? There we go. There we go. There we go. There we go. So now they tell you that this angle here, this angle here is, say, 26 degrees. Or can it be? Okay, you know what? Let's work out angle theta. Right. Let's work out angle theta. The first question, find angle theta. That's easy. Question number 2, find sine 2 theta. Right. If theta is equal to, okay, so what is theta here? Let's just, I'll work out the last question now for you, right? So obviously this here is going to be -4. That's going to be 10. 10 squared is 100. 4 squared is 16. 100 minus 16 is how much? 84. 100. No. It's 100. Yeah, it's plus. So there we go. 100 plus 16. So that would be root 116, right? So what is theta equal to? So I can use shift sign, right? So I'm just doing the first one. Your hypotenuse, that's 0. So your hypotenuse is 116. So I can go sine theta. So to answer question number 1, sine theta is equal to 10 over root 116. So theta is equal to, just bear with me, guys. Just follow what I'm doing. So we go shift sine fraction 10 over root 116. Boom. I shift sine fraction 10 over root 116. Boom. 68,2 degrees. Right. So theta is 68,2. Right. Now, I just wanted to work out this one here. Right. If theta is equal to 68,2, find sine. Now, what is, wait, let's just work out 68,2 divided by 2, 34,1. Right? Without the use of a calculator. Right, so we got the first one, 68,2. So the first question here, the first question is worth 3 marks. The second question worth 3 marks. The last question worth 5 marks. This question could also appear if sine theta equals P. Find sine half theta, because this is half of that angle. This is a half an angle. Half an angle. So let's answer question number 2. So we did question number 1. We got 68,2 for 3 marks. Find sine 2 theta. Sine 2 theta, your double angle is 2 sine theta cos theta. That's your double angle for sine. So that's 2 sine, what is theta? What did we calculate theta to be? 68,2 cos 68,2. And that will give me what? No, sine 2 theta. Yeah, I want find sine 2 theta. I want the value of sine 2 theta. No, but this is not theta. Our reference angle here is theta. So, look, you could, if you wanted to, here in this case, you could say 2 times 68,2, right? You could, if you wanted to. Or if you use your double angle is 2 sine 68,2 cos 68, or you could have said sine 2 times, in this case, because you calculated theta to be 68,2. And that will equal to, let's see if we get the same answer. 2 sine 68,2 cos 68,2. I get 0,689, which is equal to 0,69. Now, let's do sine 2 times 68,2. And I get 0. So whether you did it like that or you did it like that, 0,69, both are correct. If you broke it up using your double angle, that's your double angle for sine, or you substituted, you must get the same answer. You'll get the same marks. Right. Now let's do the next one. Sine 34,1. Let's do sine 34,1. Let's do question number 3. So we know that, okay, what was sine theta? They say without the use of a calculator. Without the use of a calculator. Wait. Right. So this is sine 34,1 or half theta. So we can start off with sine theta, and sine theta was how much? 10 over, here's it theta, 10 over root 116. Right. That is sine theta. Right. Where I want you to begin, guys, pay attention. Right. Let's start off with this. Let's start off with this. Cos 2, right. Cos of the double angle. Oh, let's start off with cos theta. What is cos? What is cos? Cos is minus 4 over root 116. Right. So this is cos 2 times half theta. Right? Because 2 times a half will give me 1. Is equal to minus 4 over root 116. So now I want sine. So therefore 1 minus 2 sine squared half theta is equal to minus 4 over root 116. I'm going to move over to the side because I don't have space. Remember, we want half the angle. We want half the angle. So I'm going to move over to the side. So start off here. Start off here to get there. This is your starting point. Start there. Cos theta, we know, is adjacent over hypotenuse. Then we make it the double angle for cos. Then we get the sine from there. Now we make sine half theta the subject of the formula. So minus 2 sine squared half theta is equal to minus 4 over root 116. The plus 1 will come on the other side as minus 1. So minus 2 sine squared half theta is equal to, let's go to our calculators. What does this give you? Fraction minus 4 over root 116 minus 1 equals, yeah, it gets ugly, minus 29 plus 2 root 29 all over 29. If I work that out. Now divided by minus 2. I'm just making sine squared half theta the subject of the sine half theta, the subject of the formula. So take this whole thing and divide it by negative 2. What do you get on your calculator? You get 29 plus 2 root 29 all over 58. Now sine half theta. Sine half theta is equal to, find the square root of this whole thing. So now we're going to go square root fraction 29 plus 2 root 29 divided by 58. Boom. Here's your final answer. Okay, here it gives you directly 0.82. It gives you 0.82. But what you could do, they said without the use of a calculator, is it? They said without the use of a calculator. So that means all we're going to do now is put the whole thing under a square root. Square root of 29 plus 2 root 29 over 58. And there we go. That's your, this is sine half theta. How did we get sine half theta? We started here. We started with cos of the double angle. Cos of 2 times half, which is 1. Yes. Oh, okay. So you want to move this? You want to move? Ish. Okay. Guys, take this one down. Take this one down. Okay, the learners can't see here. So let's put this, let me move this up for you. Okay, let's put it here. Can you see now? Can you guys still see? No. Okay, so let's just put it down. Let's shine it to Okaf. All right, let's do another one. You want to do another one with a half an angle? All right, we'll do one more with half an angle. We'll do another one with half an angle. Very important. Then we're going to do simplification, and then we're going to go into reduction and identities. How are we doing there, onliners? I know this is hectic. I know this is hectic. Just follow the process.
It's crunch time,
Follow
Mr.
the
Khota.
process.
It's
G?
crunch time.
It's crunch time now. Okay, yeah, I'm going to leave all of that. I'm going to leave all of this. Those of you that took this one down, take the next one down quickly. Right. Example number 3 in this. This is the last of this type of examples I'm doing. If, let's say, sine 32 equals P, find cos 32. Sine 64. Question number 3, sine 16 without the use of a calculator. The first one worth 2 marks. The second one, another 2 marks. The last one worth 4 marks. So here's it again. So learn this one. Here we go again. Now, obviously, if you get the last one wrong, you only got 50% for the question. Right? So take this one down. You guys want to start working on it already? Start working on it. Let me go here. Right, there we go. Right, let's go. Let's do the next one. Guys, I'm erasing this one here. We're going to be doing for the last one, we're going to be doing exactly what we did for this one. Because the last one is half of 32. It's half an angle. Then I'm going to show you 3 times an angle, 4 times an angle. Yeah, you have to know it. Right, listen to me. You need to identify that this is straight, 32, 32. 64 is double. 16 is half of 32. So these are concepts I want you to learn. So let's do this. The first thing we're going to do, put that P over 1. You got to construct your diagram. Shh, guys, in-house. Let's go. Let's go. Sine 32. So sine, we know, is opposite over hypotenuse. P over 1. They don't give you a restriction. So you draw it in your first quadrant. And then using Pythagoras, that's the square root of 1 minus P squared. Right. Let's answer question. So you must draw your triangle first. Question number 1, cos 32. Your reference angle is 32. So cos 32 is adjacent over hypotenuse. SOHCAHTOA. 90-degree triangle, SOHCAHTOA. Non-90 degree triangle, sine rule or the cos rule. We're going to get to that when I do the heavy higher order ones on 2 dimensions. So stay tuned. Some good stuff coming up. So what's your adjacent? Your adjacent over hypotenuse, square root 1 minus P squared over 1, which is equal to the square root of 1 minus P squared. There we go. That's your answer for question number 1. That's your first 2 marks. Question number 2, sine 64. So sine 64, what is the relationship between 64 and 32? Double. 2 times 32. Which is equal to 2 sine 32 cos 32. That's your double angle for sine. That's your double angle for sine. Sine of your double angle. So 2. What is sine 32 in terms of P? Is P. And what is cos 32? The square root of 1 minus P squared. And that's your final answer. So you got another 2 marks there. Now comes the last one that kills you guys. Sine 16. There's no 16 in there. 16 is half of 32. So do what I taught you in the last one. Start off with cos 32. Start off with cos double angle for your last one. And then that becomes your double angle for cos. And then bring in your sine 16. So there's a trick. There's an art to the last one. There's a trick. Trick or treat. There's trick. Huh? No, you start off with cos 32, which is cos 2 times 16. I'm going to do the last one for you. Let's do the last one together. Trick or treat. Let's do the last one. Come, guys. I know you're enjoying this. There we go. There's number 3. We start off with cos 32. Don't start off with sine. To do the last one, start off with cos 32. And what was cos 32? The square root of 1 minus p squared. Now that is cos 2 times 16 is equal to the square root of 1 minus p squared. Now cos in terms of sine, because we want sine from a cos, is 1 minus 2 sine squared 16 is equal to the square root of 1 minus p squared. Now we make sine 16 the subject of the formula. I hope by now you have mastered this. Minus 2 sine squared 16 is equal to root 1 minus p squared. The plus 1 on this side will come on that side as minus 1. So sine squared 16 is equal to, now we divide by negative, so it will be 1 minus square root 1 minus p squared divided by 2. So therefore sine 16, that's what they want, is equal to the square root of 1 minus root 1 minus p squared all over 2. That's your final answer. Wabon. Yabon. You are checking. You are checking nicely. You are checking nicely.
How's the weather in Johannesburg, Mr. Khota?
Ah, lovely, lovely. Today is a lovely weather. A little bit, it was a bit overcast, a bit windy in the morning, but today is beautiful. It's a beautiful day to do math.
Yes, to master
Every
it.
day is a good day to do math.
To master it.
You got problems. Yeah, math has problems. Math has solutions to problems, dude. Right, let's start. Right. Let's see. Okay. Right, here comes one, a reduction in terms of double and compound angles, right? In fact, before we do the reduction, so we did compound angle, we did double angle, we did half an angle. So with half an angle, here's the trick. There's the trick. Start off with cos double. So for half an angle, we start off with cos double. That's the rule, right? Onliners, give us some comments there. Maths on flick. You know, Moss. On point. On fire. Here we go. Let's delete. Let's clear the frame. Watch this one. Watch this one. Watch this one. Come on, clear the frame. I click clear. Why are you delaying? Come on, mister. There we go. Prove that sine 3x is equal to 3 sine x minus 4 sine cubed x for 5 marks. Shh, guys. This is sine 3 times an angle. That's sine cube. Don't confuse the two. This is 3 times an angle. Then we're going to do 4 times an angle. So whenever you see 3 times an angle, you break it up into compound. So let's start in our answer. Guys, all right, what I want you all to do, South Africa and the world, put down your pens. Let's do it together. Because I'm going to be writing the screen full. And if you miss any step, I'm not redoing it. I'm going to do it step for step, step by step. You need to understand each step. So we're starting on the left-hand side. It's an identity. So sine 3x. What did I say? Break it up into compound. This is equal to sine 1x plus 2x. Right. So that's your compound angle. That's your compound angle for sine. Now, what's your sine compound angle? Sine cos, cos sine. The sine stays the same. So that would be x, that would be 2x. That would be x, that would be 2x. We just expanded the compound angle. Now, my right-hand side, listen, my right-hand side is only sine. So I got a problem there, I got a problem there, and I got a problem there because I need to convert all of them to sine. So let's all do it together. Copy and paste, sine x, sine x. Cos 2x in terms of sine is what? 1 minus 2 sine squared x plus, copy and paste, cos x, there's nothing you can do with that, times sine 2x is 2 sine x cos x. Done. I'm putting a tick there. You all understand that? We broke up our double angle. What did we do? We broke up our double angles. Now let's remove the brackets. Sine x times 1 is sine x minus 2 sine times sine squared is sine cubed x plus, this is all one term, 2 sine x cos times cos, cos squared x. So I'm okay here. I got sine, I got sine, I got sine. My only problem is cos squared. Now what is cos squared according to grade 11? 1 minus sine squared. Very good. So now we got copy and paste sine x minus 2 sine cubed x plus 2 sine x. Cos squared is 1 minus sine squared. This is your identity. Grade 11. Now remove the brackets again. Sine x minus 2 sine cubed x plus 2 sine x times 1 is 2 sine x minus 2 sine times sine squared is sine cubed x. Now we are okay. Everything is in terms of sine. And that's what I wanted. Everything in terms of sine. So 1 sine x plus 2 sine x. 3 sine x. Minus 2 sine cubed x minus 2 sine cubed x. Minus 4 sine cubed x. Therefore, left-hand side is equal to right-hand side. Boom. Don't go right boom in your head. Kway, brah. Kway. Master this. Learn this. I'm going to do one more. Now 4 times. This was 3 times an angle. We break it up into compound. Now I'm going to give you 4 times an angle. And there we're not going to break it up into compound. We're going to break it up into double. So I'm going to give you guys a couple of seconds to take all this down. Asanain, how are we doing there, bro? How's our onliners doing? Are they still online?
The sparks are flying.
Learning? The sparks are
flying. You know.
So grateful for this workshop. Mashallah, Jazakallah, your Nachi 04. When maths is dalad, we to ndlovu, Boom, Musna. Simple stuff, Razin. Aren't we amazing, Iman? Kway, Mr. K. Alhamdulillah. It is simple, but you need to master it. You need to know this. You need to know this.
How's this one? Big brain.
Big brain. Pinky and the brain. What are we going to do today, Pinky? Same thing
Let's
we do
take over
every
the
day,
world.
brain. Take over the world.
Oh, help me. Help
You know
me,
that song?
Father.
Skibbity-ding-ki-ding-ki-doo, skibbity-ding-ki-doo, skibbity-ding-ki-ding-ki-doo, skibbity-ding-ki-doo. I love you in the morning and in the afternoon. I love you in the evening and on you guys don't watch cartoons, man. Ah, come on, dude. Are we 90s kids? We still...
That's before their time, Mr. K. Come on now, man.
We'll waste them. They still doff. We need to make
They're
them pop
still
off.
green. They're still
They
green.
still green. Alles
on
mos
the
green
tree.
soos 'n cabbage, me, bro. Some tomatoes for a party, some even for a flavor, madam.
Oh, help us.
Right. Let's go, let's go, let's go. You took it down. Can I clear frame? Can I clear frame? We're now going to do 4 times an angle. Let's see how sharp are you. Let's check how pop-up are you.
Here's one for you.
Here's one
comments.
for you. Let's see. On Fad... On Fadi Pernaristal to J. Vitmos Kabil to Kabal to on Fadi Pernaristal to Mr. K. Let's
No
smash
bounties
it.
here, please.
Lord of... Right, let's go, let's go, let's go, let's go. Fadi Pernaristal to. Right, here goes. Prove that cos... Shh, guys. Prove cos 4x is equal to 1 minus 8 sine squared x plus 8 sine to the power 4x for 6 marks. Tala. Yo, they talking about Mr. K's ring. Mr. K's ring. This one here is from Ertugrul, and this one here, this is Lord of the Rings, Baba. Everything makes sense. These are
We're
power
not
rings.
fighters. We're not fighters. We're lovers, Mr. K. You look like
We
Dave
roll. I'm a
Baracus.
fighter. We roll. We roll maths every day. We smash
He's a-
him. We smash
There
him.
we go. There we go.
Habib say we smash him. Come, let's go, let's go, let's go, let's go. Come, we back in, guys. After this, I'm going to give you another one to do a simplification. Then we're going to do a general solution. Then I'm going to give you a Kway one, and then we are wrapping up with, then I'm going to do the trigs on 2 dimension. There's so much, guys. I love you guys so much. I wish we could sit the whole day and just problem after problem after problem. Crack it like a boss. I know you're writing tomorrow. What you writing on? English. And what's paper 1? Language. Ah, come on. Comprehend. Are you all going to fail? You guys don't understand jack. Inshallah, no, you'll pass. No, you're gonna. Ameen. I'm gonna be making lots of dua, 2 rakat tahajjud tonight for you guys. Gonna wake up 2 o'clock in the morning just for you to say, Allah must make you all get your distinction. Inshallah, ameen. Oh Allah, answer our dua. Let all our students, whoever joined us, all get A+ in all their
Ameen.
subjects. Inshallah.
Amen. So we can move forward. South Africa can move
Amen.
forward.
Of course. Right, now watch. Let's dala. Whenever you see 4 times an angle, you make it double. Now pay attention. Listen. Mamela, open up your ears. Open up your brains. Right, cos 4x. Do not make it 2x plus 2x. You went and you did that. No, don't. Guys, the left-hand side, listen. Do not make it 2x plus 2x. You know how big the thing will become. The minute you know you're going over into your next page, you're wrong. Right, so watch here. Cos 2 times. Now my reference angle is what? 2x. Listen. I'm not doing it again. I'm doing it first time. So your reference angle is 2x. And we want our right-hand side in terms of sine. Now your cos double angle, your cos 2 times your reference angle is equal to 1 minus 2 sine squared of your reference angle. Am I right? That's your formula. So this is 1 minus 2 sine squared. Let's all say it together. What's my reference angle here? 2x, not x. Can I hit you on the head with a hammer? I hope I can push this in your brain. Here's 2 times your reference angle. Your reference angle is 2x, not x. Now watch what we do. Put your pens down. 1 minus 2. What do we do with the square? Now we open brackets. We say sine 2x. You take that to the top, squared. This is your catch. If you can't get this right, you'll get everything wrong afterwards. Learn. Because I tell you so. Right. Because you can't square. Listen, you can't square a trig function. You're squaring the entire angle. That's why you take it to the top. So this is 1 minus 2. Now sine 2x is 2 sine x cos x all squared. 1 minus 2. Let's remove the brackets. 2 squared is 4. Sine squared x cos squared x. Now let's remove the brackets. 1 minus 2 times 4 is 8 sine squared x cos squared x. My problem is cos squared is 1 minus sine squared. 1 minus 8 sine squared x into cos squared, my identity, 1 minus sine squared x. Now we remove the brackets again. 1 minus 8 times 1 is minus 8 sine squared x. Negative times negative is a positive. 8 times 1 is 8. Sine squared times sine squared is sine to the power 4x, which is equal to right hand side. Bada bing, bada boom. Slat it like a hond. You guys' minds are filthy, man. I'm gonna move you. I'm kicking you out of this workshop. Man, I can't deal, man. Hasanain, I'm
What's
kicking
happening,
them
Mr.
out.
Khota?
I need a
What's
censorship
happening?
board here in-house, brother. My matrics
What
are here
is
off the
happening?
hook, bruh.
What is happening? Who do we need to boot out of the
So we need
studio
to
there?
I need to boot them all out.
What's happening there, Mr.
They say
Khota?
I rubbed off onto them. They're talking lies. I'm well
Jesus.
behaved. 2 days I'm on best behavior, bruh. I'm getting stars.
Can we hear a testimony from one of the witnesses there? Because we
To
can't
say
only
what?
take it from your side. No, we want to hear what was said.
Oh no! Oh no! Stuff. No, never. I can't put that on national.
Is it?
No,
But
my
maybe it
guys.
was
No.
mentioned already.
I got rough lighties here in this class here, bruh.
Is
Rough
it?
and on the
Rough
scoff.
Is it? And they don't even talk
They're good.
Afrikaans.
Nuxie, my bro. Nuxie. Alles nuts lekker hier. Right, let's go. We done with this one. Let's give you. I hope you guys understood this one. Master it. Master. Kung Fu Master. Round 2, fight. Let's go. Right, put you out. Right, I'm clearing the frame. I am clearing the frame. Right. I got good kids, man. They get a little out of line, little bit like me, and then you smack me in line, isn't it, Hasanain? So I smack them in line. So let's go. We're
Yes.
done here. We're done here. We're done here. Okay, let's go. Check this one out, guys. Let's crack this one. They tell you determine without the use of a calculator the value of the next. So they tell you sine 2x cos minus x plus cos 2x times sine 360 minus x. This is straight out of a past paper. All over sine 180 plus x. Guys, what if we told you that next week Thursday we do it at the Centon Convention Center and all of you come live? Will you come live? Let's hear.
I'll come.
If this was, you'll come. Of course, I have
Yes,
to have
I
a
will
Sanane
come.
there.
We'll have nice
Yes,
samosas.
I'd love to meet all 250,000 of you live. Yes, as you know what a time we'll have. Boot camp, 2 days.
No, but Mr. K, that will be your coronation. We will give you the king status. We'll give you the
Nothing
throne.
like that.
That will be your coronation.
We'll try and invite Joey Rasdin for comic relief as well.
Mr. Khota.
Mr. Khota. Remember, guys, try it while you guys doing it. Just a reminder, next week, Thursday, this coming Thursday, from 4 p.m. to 8 p.m., math paper 1. Before break, I'll put down all the details. Or 9 or 10. Whatever time you guys want to do it. With Thursday, the night before paper 1 or the day before paper 1, this coming Thursday, 4 o'clock to 9 p.m., 4 p.m. to 9 p.m., Saturday, 9 a.m. till whatever time. We can even have supper here together. Yeah, no problem. We'll put up our details. It's a private workshop. Don't flood Hasanain's inboxes. I'll send you the WhatsApp details for the booking. The link will go live tonight.
Emails, Mr. Khota.
You're already getting
emails. Yes,
Well,
because you know why? No, you need to have a certain time during the session where you can unpack all of that.
We will unpack all this before break, Hasanain. Just before break.
Properly.
Let's go, guys. Let's simplify. Are you done? Are you done? Are you done? Hasanain, inshallah, next year, Centon Convention Center, Durban ICC, Cape Town Convention Center, live.
Okay.
I know all you guys will come live, isn't it? Even if you matriculated this year, you'll still come for our live workshop. Right, let's go. Now watch. Let's do this together. That's the dream. We're getting our dream. Inshallah. Right, let's go. Sine 2x. Guys, do me a favor. Don't break it up. Don't break up now. Don't divorce. Don't talak it now. Sine 2x. Cos of a negative angle is cos x plus cos 2x. Sine 360 will remain sine x. 360 minus is in your fourth quadrant. Sine in your fourth quadrant is negative. Negative times your positive. This whole sign in between becomes negative. All over. Sine 180 will remain sine x. 180 plus is in your third quadrant. Sine in your third quadrant is negative. Yes! You didn't see that one coming. Sine, cos, sine. 2x, x, 2x, x. Do not break it up. This one needs to be reduced, not expanded. If you expanded it, you're wrong. So now this is your sine. Yes.
Just give me a few minutes. I am taking a comfort break. I'll be back shortly. Do not panic if you do not hear my voice.
Okay. What time are we going in for? What time do we go for break?
Let's have a look here.
12:30?
There we go. It's on the screen.
Yes, 12:30. Good. We're moving on. Fantastic time.
Okay, so just excuse me for a few moments. I'll be with you shortly.
Thanks for the info. Let's go back, guys. This is your compound angle. This is your compound angle for sine. Sine, cos, sine. So this here is your sine compound angle 2x minus x. The sign stays the same. Remember, if this was a cos compound, that sign would have changed. Here the sign stays the same. Over minus sine x. That is equal to sine. 2x minus 1x is 1x over minus sine x. Positive divided by negative is a negative. Sine x divided, anything divided by itself is 1. They could even convert this one to an identity and say, prove that this is equal to minus 1. Then you'll just say, therefore, left-hand side is equal to right-hand side. Well done, guys. You guys all got it right here in-house. Who went and expanded the 2x and the cos 2x? Someone did. Tasneem. And halfway you just bombed out. Well done, guys. Well done, well done. Well done, all our onliners and our in-house learners. Let's give you... No, it wouldn't. You won't. I'm telling you, you would have taken the garden route to get to Cape Town. It's beautiful. You wouldn't have, I'm telling you, you wouldn't have made it in time. But anyway, good. I hope you all took this one down. Check the next one out. Higher order question. All right. I'm going to do this one and then I'm going to do one general solution. And then we'll do trigs on different planes. All right, here goes. Take a deep breath, guys. Take a deep breath. If x plus 1 over x is equal to 3 cos A and x squared, show off. Who's like you, bruh? Is equal to 2. Right. Find cos 2A without the use of a calculator. Find cos 2A without the use of a calculator. Have you ever seen so many learners collectively, 250,000 learners, having so much of fun doing maths? More maths this weekend than you ever did at one sitting in your whole bloody life. Unless you have been to Kway workshops before. Yeah. In fact, what I'm going to do on Thursday, I'm not going to stop until you guys tell me to stop, until you guys step out. You know that moment when Khabib had McGregor like this, and then all you just see is. So I'm writing with you. When you write, I'm also writing your paper. I'm going to my closest school, and I want to see whether I can finish the paper in 1 hour. The record to finish your 3-hour paper is 46 minutes and get 95%. Don't worry, Elon Musk decided he's going to do this telepathy thing where you can plug in. Come.
Okay, moving on.
Okay, finish up now, guys. Finish up. Oh, you're waiting for me to do it? Yo, check these O's out, brah. Waiting for you to do it. Question, answer. Ha! So now they got a square in a problem. Watch here. Right. They give you condition number 1 and they give you condition number 2. Condition number 1 got no square. Condition number 2 got a square. So the only thing I can do with condition number 1 is to square it. So watch. You square the entire side. X plus 1 over x all squared is equal to 3 cos A all squared. So now let's square it. Square the first term, x squared. Multiply the 2 inside the brackets and times it by 2. So x over x is 1. 1 times 2 is 2. Plus, square the next term. 1 squared is 1 over x squared is equal to 3 squared. Tasneem, are you following? 3 squared. Yeah, you following that side. Follow this side. 3 squared is 9 cos squared A. There we go. So we expanded. All I did there was I expanded. Guys, come. Right. So there we go. Right. Now they tell you, listen to me. So now you expanded on this side here. Let's see. They tell you x squared plus 1 over x squared equals 2. So x squared plus 1 over x squared equals how much? 2. So let's put, instead of this, let's put 2 plus 2 is equal to 9 cos squared a. So you can say here, but x squared plus 1 over x squared is equal to 2. Therefore, that's your x squared plus 1 over x squared is 2. So 2 plus 2 is, you're so clever, grade 1s, is equal to 9 cos squared a. Right. So now cos squared a equals 4 over 9. So I get cos squared a is 4 over 9. And that's as far as I can get with that. What did the question say? Cos 2a. Now cos 2a, listen, cos 2a in terms of cos squared is 2 cos squared a minus 1. That's your double angle. So 2, what is cos squared a? We found it out here. What's cos squared a? What's cos squared a? 4 over 9. So instead of cos squared a, what can I put? 4 over 9 minus 1. 2 times 4 is 8 over 9 minus 1. Here's your final answer. Here's your final answer. 8 over 9 minus 9 over 9 minus 1 over 9. And that's your final answer. Work of art. Work of art. Beautiful. Beautiful. 5 marks. 5 marks. Let's hear our onliners. Did you all get it right? Onliners. Let's hear our guys that are coming. No, you can't square root it. How's our guy from... No, Mr. Madao left the building. Kiro Academy. Well done. Well done. Well done. Well done. Well done. Our guys from UK. Our guys from UK. Are you still following it? Are you still following? Why did I square it? The question, why did I square it? Because I needed a square in the question. Because here in my condition, they gave us another condition with a square in it. So I had to square this side. How will I get it from that to look like this with a square? You have to square both sides. Compulsory. You can't do it any other way. What we call it in Islam, fard. You know fard. Fard means compulsory. You have to do it. It's fard. Right. So we're done with this. Let's do a general solution. Let's do a general solution. You must square both sides to get a square into your problem. Whenever you want to introduce a square into the problem, you got to square both sides. So well done to those who got it right. Or I know this question showed some of you flames. Right. Let's do the next one, guys. Let's do the next one. I'm clearing the frame. Let's do, they tell you give the general solution. Give the general solution. Now, guys, again, I'm telling you, I'm only doing certain selected problems. If you want a variety or if you want some other problems and see how it's done, go back to our previous Okaf session. It's on the Okaf website, that video. We've done all the different types and styles. So you'll be using this weekend's workshop, plus last weekend's workshop, plus the Kurtuba online, plus all our online videos. That would give you your distinction. I mean, 6 sine squared x plus 7 cos x minus 3 equals 0. Right, for 6 marks. This is straight out of a past paper. I'll even tell you which past paper this one came out of. Department of Basic Education, November 2020. This one comes out of November 2020's final paper.
Nice. I like that, Mr. K. I like that about you.
Why? What did I
You're
do?
always doing the right thing. This is the right thing.
Got to show them every question that we do, our potential exam. It's basically over these 2 days. We just writing our final paper, but we're extending it over a period of time to explain to you different scenarios.
Remember Spike Lee came out with a film called Do the Right Thing.
Yes.
This is doing the right thing with
Spike
Mr.
Lee
K.
joint.
There we go, with Okaf
Spike
and
Lee
Kway.
joint. Okaf and Kway joint.
Yes.
In our answer. Right now, there's no compound or double angles here, but what you want to do is you want to make it quadratic. What do you want to do, guys? You want to make it quadratic. 6. The sine squared is 1 minus cos squared x plus 7 cos x minus 3 equals 0. 6 times 1 is 6 minus 6 cos squared x plus 7 cos x. I know you're loving this, guys. I know you're loving this. I know you're seeing it. Minus 6 cos squared x plus 7 cos x. 6 minus 3 is 3 equals 0. Divide by negative 1. So what do I have? 6 cos squared x plus minus. Let's go. Remember, I'm not working with memos here. I'm doing it with you as if we are doing it in the exam. And this is not rough calculation. Exactly the way we unpack it here is exactly the way you unpack it in your exam. Right. Minus 3. Let's see. Minus 3 is equal to 0. Ha! Now comes a point where you need to find your factors. If you got your if you don't know how to do it, we're going to use Mr. Snotkop. You know what is Mr. Snotkop? Let me show you Mr. Snotkop. Now we need to factorize. So here's your face. There's your face. There's your eyes. There's your nose. There's your mouth. There's the tears. And there's the snot. Right. So let's do.
You got to be kidding me.
No, I'm serious. I'm not joking. Mr. Snot, what are your eyes? The first and the last are your eyes. 6 and 3. What is your nose? You think I'm joking here, bruh? The only thing more serious than me today is AIDS. Multiply by. Oh, right. And what goes in your mouth? Minus 7. So the snot drips into your mouth. Yo, what a beautiful picture.
Salty.
Right, let's go. What are we short of here? We short of, so we got the eyes, the nose, the mouth. We are short of our 2 factors, the tears. We're short of 2 factors, the tears and the snot. So let's go. 3 and 2. 3 and 1, 1 and 3, 1 and 3. So there's your tears, Hassanain. There's your tears. The tears are your factors of your eyes. 2 factors. Now we cross multiply to get the snot. So Mr. Snotkop, 3 times 3 is 9. 2 times 1 is 2. There's your snot dripping into your mouth. Minus 9 plus 2 gives me minus 7. Negative times positive is a negative. So we know we write bracket number 1, bracket number 2. So watch what we do. So they tested Mr. Snotkop in your exam. 3, 1, 2, 3. 3, 1, 2, 3. Cos times cos to give me cos squared. Which one gets the positive? Which one gets the negative? We start from the 2 inside. 1 times 2 is 2. I need plus 2. I put plus. 3 times 3 is 9. I need minus 9. I put a minus. Boom, Mr. Snotkop is done. And now we got our two factors. So 3 cos x plus 1 equals 0, or 2 cos x minus 3 equals 0. Let's solve for x. Cos x will equal to minus 1 over 3, or cos x is equal to 3 over 2. This one, no solution. Why? The maximum value of cos is 1. 3 over 2 is 1.5. So no solution. You can check it on your calculator. No solution on this side. Or x is equal to, let's go on that side. Shift cos minus a third. Shift cos negative 1 over 3. Boom. I get plus minus. For cos, you put plus minus 109,47 plus k times 360, where k is an element of integers. And there we go. There's your 6 marks. So apply, Mr. Those of you who your schools don't allow you to take your factorizing calculators in, or your silver calculators in, you use Mr. Snotkop to write. I don't know. Some schools don't want you to. I don't know why. It's not a departmental rule. So if you got the silver calculator, or you got this Casio here, the fancy one, it factorizes for you. But you know what? It only gives you your two solutions. They'll probably want to see exactly how you broke it up. You're going to be forced to use Mr. Snotkop. And then work backwards. Okay, yeah, no problem. Whatever. You can even use... Yeah. Please use Snotkop. Okay. Onliners, did you get that one right? How much time do we have left? We've got 15 minutes, boss. Jessica Appia, I got it. Where does Mr. K? Well, I came up with my own methods. Yes, you're getting it right. Keep going. My tricks are really good. The drawing is killing me. Wait. Wait. Right. Okay, can I show you guys can I show you a joke before we go? On a lighter note. Hasanain, are you there?
I'm falling asleep here. It better be a good joke.
All right. So you want something that's going to crack you up for life for days.
Mr. K.
All right. So you got Johnny, right? You got Johnny. Now Johnny is an ADD. Johnny is an ADD kid. Johnny is an ADD kid, right? So the teacher knows that not to ask Johnny to do anything in class. Anyway, this principal walks into class and wants to see how clever this kindergarten grade 1 class are, right? So anyway, the principal walks in the class, and the principal says, right, today I want to see how clever this grade 1 class is. So anyway, the principal draws that on the board. Right. Who can continue with the story here? So anyway, Johnny picks up his hand first. He's like, Mr. K. Me. I said, not you, Johnny. Okay. Huzaifa, come to the board. So Huzaifa comes to the board, and Huzaifa draws that. So the principal asks, what is that? Huzaifa says, that is the house on the land that you drew. The principal was mind blown. Round of applause. Right, who else can continue with the story? Here, the teacher puts a hand on her head. Johnny Pick says, me. The teacher puts a hand. The teacher says, no, not you, because I know, Johnny, the picture is not yet safe enough for Johnny. So, all right, Zahra picks up a hand. Zahra comes up there. No. So, they give Zahra a chance to draw. What is that, Zahra? That is the door on the house, the land that the principal drew. Yes, what a brilliant answer. Now Johnny is getting upset. Johnny is now hitting the table, snot and trana, jumping on it. Please, me. Teacher says, no. Isa come up. So Isa comes up and Isa draws that. What is that? That is the sun on the house with the door on the land that the principal drew. Yes, like I'm telling you, the principal is like mind blown, right? Hasanain, you following?
Yes, indeed. Yes,
right.
Indeed.
Right. So anyway, the teacher thinks that this drawing is as safe enough. Anyway, Johnny is now crying, bruh. He wants a chance. Yo, that principal asked the teacher, why don't you give that little boy a chance? He's crying and he's screaming there. Let him please come. So anyway, the teacher
Ooh,
allows him.
Yara.
The teacher puts a hand on her head, says, all right, Johnny, come to the board. Yo, Johnny is wiping his tears. He's so smiling now, walking to the board. Johnny comes up and Johnny draws that. The principal, the teacher asks, what the hell is that? He says, that's my father in the bathroom bending over to pick up soap.
Oh, yeah. Oh my God. 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 That's a PG-18 there, Mr. Khota.
It's gone.
That's,
Clear frame.
yeah,
Clear
please,
frame.
please.
Clear frame. Let's go back
That's
to
a
back.
red card. That's a red card.
Red
and
card.
if you sit,
I'm getting kicked out of here, Brad. That
yes,
one there, I know I'm
you
getting
to sit
kicked
in
out.
the naughty boy corner, please, Mr. Khota. We
Let's
can't
go.
do this here.
Let's
It's a family show.
It's a family show. Let's go, guys. Let's go. Let's go.
But
Let's
I
go.
suspected that joke was a little bit suspect because the boy's name was Johnny, you know?
Hey,
That's a dead giveaway.
No. That's a dead giveaway.
PG-18.
Johnny is rough, bruh. I know a whole story, right, of Johnny, but I can't do it here. It starts. Probably it's about a 20-minute saga of Johnny. But yeah, he just
Yeah.
messes it up royally. So that's X, that's beta, that's alpha, that's beta, that's X. All right. Let's go here. Let's go here. Let's go there. That's angle theta. Prove that PS. Prove that PS is equal to X sine alpha over sine alpha plus beta cos theta. How's our onliners doing there? We're going to be doing 2-3 questions here. Yeah, pray for me, Razin. Pray. Johnny sins. Pray for Johnny sins. Read namaz. Astaghfirullah. Astaghfirullah. They say they're praying for Johnny and myself. I need prayers.
For both sides.
For both sides. Let's go, let's go, let's go, let's go, let's go. Sure. Right, finish up. Let's see how well you guys do this. Now the dotted line is parallel. The dotted line is parallel to that line. No. This is not Johnny's house, but Johnny, don't stay here. Johnny is trailer trash, bro. This is PS. Let's go. Right, in our answer. Guys, we don't have much time. I'd love you guys to do this on your own, but you know what? Let's color this one together. So that line, so that is theta. Now remember, this is triangle 2, that's triangle 1. We start in triangle 2. I want to rename the common side QS. So what do? This angle here, that angle there is 180 minus alpha plus beta. Right? Sum of angles of a triangle. That's how I'm going to get the alpha plus beta in the question. So now we're going to say QS over sine alpha. I'm doing the sine rule. Is equal to x over a side over sine of its opposite angle is equal to any other side over sine of its opposite angle. All right. No, the opposite angle is 180 minus, sorry. It's 180 minus alpha plus beta. So it's sine 180 minus alpha plus beta. So we want QS on its own. So QS is equal to times this side by sine alpha times that side by sine alpha. I'm going to get x sine alpha. There we go. X sine alpha over sine 180 reduction will become sine 180 minus will fall away. Sine is positive, so it will be sine alpha plus beta. And there we go. That's what QS is. So now I got QS. The question wants PS, wants that side. So if that's my reference angle, that's my opposite, that's my hypotenuse, that's my adjacent. So I need these two sides. So adjacent and hypotenuse is what? From SOHCAHTOA. From SOHCAHTOA. Adjacent over hypotenuse is what? Cos. So now we're going to go cos theta is equal to QS over PS. So let's go. They want PS on its own. So therefore, PS over QS is equal to 1 over cos theta. There we go. I flip this side. I flip the other side. So now they want PS on its own. Therefore, PS is equal to times QS on this side times QS on that side. I have QS over cos theta. Therefore, PS is equal to, instead of QS, what can I put? That whole thing there. So I got X sine alpha over sine alpha plus beta. And cos theta is at the bottom. So we leave cos theta at the bottom. Boom. Which?
X sine.
This, yeah. Qasam, wallahi, that's an X. What?
If you wanted to component,
I don't know. You can try.
I say Q, you are a P will be 190 minus theta. It change to cos theta either way.
Yeah, okay, okay. You can do it, but this, yeah, is a straightforward way to do it. Right. In fact, no, before we go for how much time do we have? Hey, we got 5 minutes. 4 minutes to go, 3 minutes to go, 2 minutes to go. Let's see in 2 minutes whether you can do the next one. Let's wrap this segment up with the next question. Half an hour till 1 o'clock. Then we got 1 to 2:30. Then we're going to do Euclidean and then some finance and probability. In fact, the probability is everything that we've done. So whatever, if we don't, we'll see how far we work according to time. But we've covered the whole of finance. I've covered in the previous show. And you remember Jomo?
Yeah.
You remember Jomo? We took the saga of Jomo and we went through the entire finance. So we'll check our timing. If we don't have enough time for the finance, then we'll just have to refer back to the previous show. But it's exactly the same. There isn't any higher order questions in the finance. But one thing I have to show you is probability, factorials and fundamental counting principle. Yeah, and Euclidean. I have to do some similarity and proportionality. There again, I'm going to choose one model from a past paper and we'll crack it. But the main thing is to identify when to use proportionality and when to use similarity. Yes. Yeah. Okay, but I'll show it to you. All right, you guys took it down. How's our onliners? Onliners, we doing okay? Last one.
Yes.
Get ready for the last one. Last one before break. Let's clear the frame. Let's clear the frame. This one came out of a past paper. Let's do this one. Shh. Let's do it together. Take this one down with me. Take this one down with me. Let's go there. Let's go there. Let's do this. Let's do that. There we go. That is H. This angle here is 2 beta. Whenever they give you 2 times an angle, you know for grade 12s, your double angle is involved. That angle there is angle beta. This is BADC. BAD, like Mr. Khota. He's just bad. Downright bad. And C. Right. First, find AB in terms of H and beta. Find AB in terms of H and beta. That's question number 1, only for 2 marks. And the last one, find AD. Find AD in terms of H. And that is for 5 marks. So 5 and 2, 7 marks. If you guys want to, let me just see. That's AD. Anything else? Yes, they tell us that that side is equal to that side. Right. There we go. That's going to take us to break. You guys, if you want to, during break, you can crack the question. During break, you can crack the question. Otherwise, do what 99.9% of you are going to do. Wait for Mr. K to do it. Guys, right, while we let me just, we've got about a minute left. It's 28, it's 29. Ahmed, go for break. I'll see you after. Hasanain, I'll see you. We reconvene at 1 o'clock, Hasanain. Where's Hasanain? I see Hasanain is there on the phone. Hasanain. We cutting for break now. We cutting for break. We cutting for break. And I think we will resume at 1 o'clock. There we go, there we go, there we go. Enjoy your break, enjoy your break, enjoy your break.
What's happening, Mr. Khota? Mr. Khota?
Hasanain, Hasanain, Hasanain.
Yes,
So there.
yes.
Okay,
So this
okay,
is the
okay.
program over here.
Oh, so we're
have
going
a
to go till
look here.
1:15.
Yes.
Oh, so we're giving them
yes.
45 minutes. Okay, so let me just put it up on the screen as well till 1:15.
Yes. I was wondering where you were going, Mr. Khota.
We resume at 1:15 p.m. There we go, there we go, there we go.
So are you carrying on or are you resuming with your break?
No, we're going to break now. We're going to break and
Okay, so that's Mr. Khota. So we will be resuming at that time. So we'll have a break. And we have a special guest that will be joining us at 10 to 1. 10 past 1, and that is Ashraf Garda. He will be giving us a word of motivation. So he'll be joining us just before we resume. So I hope that you guys get some time to replenish yourself. So we'll resume at about 1:15. All right, guys.
easy one. Number 2, find
Welcome back, learners. So it's just gone just after 10 minutes past 1. You are tuned to Okaf SA's online maths workshop with Okaf South Africa and our partnership with Kway Maths Institute and the Department of Education. So we will be resuming shortly. But before we do that, we have a special guest on the line, and he's going to be speaking to us. It's none other than Mr. Ashraf Khota. He is a veteran journalist, and just by way of introduction, he's quite involved in a great initiative called Champion South Africa. And we do know Mr. Ashraf Khota. He used to have a program, a radio program on radio, SAFM, and also is very well known as a presenter of a program on SABC called Special Assignment. And he's also had a stint on 5FM, and is quite involved in lots of things in the media space. So we're going to call him on, and he's just going to address some of you as the participants. A word of encouragement and motivation. So without delay, let's call on Mr. Ashraf Khota. Assalamu alaikum wa rahmatullahi, Mr. Ashraf Khota. I hope that you are well. Hope that you can hear me. Hope that you are well on the Sunday afternoon. You know, we're doing a upgrade maths workshop online for grade 12 learners as part of the preparation for the final exam.
Well, walaikum salam. Thanks for the invitation. And let me say this on the Sunday as I address this massive audience of matriculants. I'm busy. I have other things to do. I have tire punches to sort out. I've got shopping to attend to. I've got reading to do and what have you. But when the invitation came from yourself on behalf of Okaf to say, can you speak to the nation, right? Because that's who this audience really is. Then, like, what a privilege and what a responsibility for me. So yes, I'm busy, and yes, I've dropped it all to give you a few minutes of my time because I think it's that important. Okay, so let me do that firstly by saying that this, and I want to address the audience on this, and whether you are able to scream it out or even just put this in the chat line, do this. Let me ask this to all of you, right? I know you're studying for Matric. I know you're specifically studying for mathematics, and you need to crack that subject. We know that. But here's the question to you. What is your purpose? What is it that you do or you want to do that is the overriding factor why you need to pass your Matric and pass mathematics and get a job and do everything else? What is your purpose? Right? And let me tell you, your job is not your purpose. Your job is the result of your purpose. Passing mathematics is not your purpose. Passing mathematics is the tool for you to get to your purpose. Passing Matric is not your purpose. Passing Matric is the tool for you to get to your purpose. So let me help you with the answer to your purpose by giving you my purpose. You see, my purpose is to champion people. So when I see people like all of you, my purpose is to inspire you in such a way that you become best in class at what you do. And therefore, my purpose is to champion you, okay? Because in championing you, right, I then raise the numbers of champions in our country because we need champion people, over 1 million champion people, to then fulfill my bigger purpose, which is to build South Africa into a champion nation. So we can't get to champion nation status if we don't have enough champions in our country. So my purpose, firstly, is to find people and to amplify them, and therefore they call me the champion spotter, to spot the champions of those who are champions and to find those who are not champions and to inspire them to become champions, because champion people build champion nations. Now, that's my purpose. So the question to you, once again, think about it. You can even answer it in the chat line. I want to know from you, what's your purpose? Okay, so that's the first thing. The second part that's really important is, what is South Africa's national purpose? So let me help you. In 1988, before apartheid ended, the purpose was end apartheid. In 1994, it was reconciliation and nation building. In the build up to 2010, the World Cup, it was 2010 World Cup. What's our national purpose now? Do you know? Do I know? In fact, we're all battling with what our national purpose is. Now, it's something that every one of you needs to pay attention to. What is your purpose and what is the national purpose? And if we don't know what the national purpose is, then I'm going to suggest all these young, bright South African young people in Matric needs to agitate to people like myself and to government and to everybody else to say, let us find and develop a national purpose, a one issue that we can put everybody together so that they can drive that as a national purpose in the same way we said, and apartheid, truth, reconciliation, 2010 World Cup, all those things were purposes. So what's the national purpose? Now, the second point about that is, can you link your purpose to the national purpose? You see, when you pass your matric, and I hope you do, and you do well, and you do well in mathematics, right? It's one thing being best in class. It's another thing linking your skills now to the national purpose. If you don't link your skills to the national purpose, then in fact, it's only for yourself. It's like you got the fanciest house in the street and the entire community's got nothing. Can you link your purpose to the national purpose? So I'm going to encourage you to do that. Be the best in class. And I like to think the day that you have your matric results and you've done really well, I want you to say the way rugby players do, like Siya Kolisi, you know, when he wins the World Cup, he says, this is for South Africa. So can you link your national purpose, your purpose for matric and say, I'll do well in matric. And when you get good results, you say, this is for me, this is for my family, but this is for my country. Why? Because the country needs champion people to build champion nations. And if I finish my matric, well, I'm a champion in my space. So that's the message for all of you, okay? Link your purpose to the national purpose and be a champion at what you have to do. Now, the final thing, Champion South Africa, the project that I head up, is a project with the clearest goal in mind to become a champion nation. That means what? It means best in class in education, best in class in mathematics, best in class in rugby, cricket, football, best in class in terms of safety and security, best in class in terms of prevention of gender-based violence, best in class in terms of eliminating inequality in our country, best in class in giving people the best opportunities possible for them to being able to live their best life in South Africa. That's our goal as Champion South Africa. Now, for that to happen, we don't only need over 1 million people to be best in class. We also need institutions to be best in class. So what we say is, when we say champion people build champion nations, we also say champion institutions build champion nations. And that leads me on to Okaf. And I want to say this, I've known Okaf for a good number of years, and I have no doubt that Okaf is a champion institution that helps us to achieve our goal of building a champion nation, because Okaf spends a lot of time and a lot of effort and a lot of makes a lot of serious interventions like today to try and ensure that you are best at what you do. So to the team from Okaf and to the audience, wherever you may be, let's acknowledge the incredible role Okaf plays as a champion institution, ensuring that we are champion communities multiplied across the length and breadth of our country, because champion institutions with champion communities and champion people like all of you ultimately will deliver on our desire to become a champion nation. So as you get to your post-lunch session, I want to advise you, think about what I said. What's your purpose? What's the national purpose? How do you link your purpose with a national purpose? And once you got that right, believe me, nobody will motivate you or need to motivate you to pass your mathematics exam and to pass your matric exam, because your purpose will be bigger and higher than every one of those things. You'll be just too ready to say, give it to me. I know my purpose. I want to drive myself, and drive it you will. Thank you.
Thank you so much, Mr. Ashraf Khota. Thank you so much for your time. And then while you are backstage, you can have a look on the screen of some of the comments. So we've been inundated with comments around what builds a champion South Africa, a champion nation. So with this project, Okaf strives for us to strive towards that excellence in performing great results in mathematics, and hereby we are able to become, like Iman says, become a psychologist to help people with their mental challenges. What about solving corruption in our country, right? That's something very important. What about load shedding? So if we have some more engineers on board, we can put a into to load shedding, right? What about ending poverty, right? So this is a very important question, and we would like to thank Mr. Ashraf Garda. And as Mr. Khota comes on, we'll also just flight those questions on screen. Mr. Khota, while you're getting yourself prepped, I'll just put on the, you need to unmute yourself. There we go.
There we
You're
go.
unmuted.
There we
Very
go. There we
inspiring
go.
words from our veteran
Yes.
journalist and champion South Africa, a champion of the Champion South Africa project, you know. So I'm just going to
Excellent.
flight on while you're getting
We're
ready.
loving all the comments. Just like to thank Mr. Ashraf Garda for coming on and giving the inspiration and the motivation that we require. And that is the purpose of all what we are doing to build a better country. The country is only as good as its people. The country is only as good as its hero. Yes, Joseph Mashangwani, we need heroes in every sector. And ask yourself, are you going to be the next hero? Are you going to be the next hero? What legacy are you going to leave?
Champion Nation.
There we
Yes,
go.
let's go.
Hashtag
Let's
Champion
go.
Nation. And I think that is exactly where we are, and this is where we need to be. And that's why we are doing what we are doing. We are breaking our back for you guys here at Okaf, at Kway Institute, to make sure that you guys go
How's this
and
one?
get the very
My
best.
purpose is to kill maths on Friday.
That's it. Destroy. Complete destruction. Right. To smash it. Pass math like a champ. Well done. Well done. Well done. Guys, we are back in session. Thank you, everybody. We have got Kota Musk. I wish. Alhamdulillah. No. We don't need to leave South Africa. We don't need to leave South Africa. We need to build this country. We need to build this country, and we need to build it to the best of our ability. We still have the best intelligence, the best academics in this country to make the much needed difference that the country requires. Anyway, guys, let's go back. Hassanain, are we ready to flight our last segment for today? Hassanain, are we there?
Yes, we are. We are.
All right. Can we go live, brother? Okay, we're going into Euclidean. So I've taken this diagram down, taken it out from a past paper. You guys can take this one down as we work. I've got so many people that have still been WhatsApping me during the break to say that they're watching the pre-recordings because it's going up live. People are watching. They haven't gotten to certain parts yet already on the show. But yeah, thank you, South Africa, and thank you, the world. Thank you, UK, Australia, the African nations, and the whole of South Africa for joining in this groundbreaking paradigm shifting initiative. Guys, we are going to be ending now with Euclidean and probability. I need to explain to you guys the factorials and fundamental counting principles. Oh, we had that question before break. Do I open up a new frame? Let's open up a new frame. Let's see, can we flip between the two? Okay, we had a question before break, which I left you with. So you've taken it down. I hope you had time during break to do that one. In fact, let's do it together. I'm just going to redraw that. Whoa, let's not go there. Let's start here. Let's draw this. It went like that. It went like this. That was 90 degrees. That was our point. That was 2 beta. This was angle beta. That side was equal to that side. I remember this was BAD, BADC. There we go. The first question, and this was H. So first question, question number 1, they wanted AB. So let me go here. Let's make this 100%. They wanted AB. They wanted AB. They wanted that side in terms of H and beta. So this triangle 1, which is in triangle, I'm now looking at in triangle ABC. In triangle ABC. What do we have here? We know we want this side here, right? So we know I can use SOHCAHTOA. So I'm going to say sine beta. So let's go. Sine beta is equal to H over AB. Right? Opposite over hypotenuse. Opposite over hypotenuse. Sine AB. So what do I have here? I want AB. So AB over H. AB over H is equal to 1 over sine beta. So AB is equal to times H on this side times H. H over sine beta. So there we go. AB is H over, let's write it better. Let me erase that. H over sine beta. So let's put it there. Let's choose a different color. So this side is H over sine beta. There we go. And that's your first. How many marks was that one? 2 marks. 2 marks. 2 marks. I'm just flipping the page here. Let me see. I still got my diagram there. Okay, good. Onliners is everybody in? Everybody in? I hope you all got that one correct. Yes, this question appears in most previous questions. You're right. You are 100% correct. Nana the Small. You are correct. Where you are from? Where are you? Where you are from? How's my English? Nana the Small. Where are you from? Welcome to Kway the Big. Right. The big workshop. Let's see. Right. Okay. We are deleting this. Let's answer the next question. Right. What was the next question? I hope you guys all got this one right. We got all that one correct. Let's check all our comments that are coming in. Are we all good there, Sanane? We are all good. Let's go back. Let's make that 100%. Let's go back here. And we're answering question number 2. Now they want AD. They want AD in terms of H. So what do we have here, guys? We got H over sine beta. This is an isosceles triangle. So that will also be H over sine beta. Yes or no? Now I'm looking at triangle. Let me just highlight this triangle for you. I'm now looking at this triangle here. ABD. I'm now looking at triangle ABD. So let's go. Let's say whoa, how's that, bruh? In triangle ABD. Right. So now we're looking at this triangle here. There's our reference angle, 2 beta. I got 2 sides. I've got 2 sides and the included angle. What rule do I use? The cos rule. Did you guys manage to do that during the break? Did you guys manage to do that? Did you identify that during the break? If you're not able to identify that, guys, you are in trouble in Monday's paper. Right? Remember, 2 sides and the included angle. Who says my goal in life is to be like Kway? Who says my goal in life is to be like Mr. K, in going around the country and make sure that every single learner understands mathematics? Ria Betswe, what you say, my child? How many more Kways are we going to get? I might die tomorrow. Who's going to take over my job? God. That's correct. Become engineers. Let's go. So we're going to do the cos rule. Let's do the cos rule. So AD squared is equal to H over sine beta squared plus the other side squared, H over sine beta squared minus 2 into H over sine beta into H over sine beta and multiply by cos of your included angle, 2 beta. I hope you got that, guys. I hope you got that. Suleiman Imandin. Welcome to the show. What hairline? I got no. You trying to make fun? My hairline.
Yellow card for that joke.
Yellow card for that joke. No, it's fine. H squared over sine squared beta. I'm absolutely confident about my hairline. H squared over sine squared beta minus Now what do we have? 2h times h is 2h squared over sine squared beta. And what do we have? Cos 2 beta. Right, we're going back in. AD squared is equal to. Hey guys, let me tell you a secret. I'm a big Andrew Tate fan, so. Right, so 2h squared plus h squared is 2h squared over sine squared beta. I think two of the most hated people on the planet at the moment being Andrew Tate and Kanye West, and yeah. Right, minus 2h squared over sine squared beta. And then we have cos 2 beta times cos 2 beta. Right, AD squared is equal to. Right, let's go. So we're now going to take out the highest common factor of 2h squared over sine squared beta into 1 minus cos 2 beta. I took out the highest common factor. Remember, this is one term. Many of you do this in the exam. You cancel that and you cancel that. How can you do that? Ever. These are two separate terms. That's one term. That's a separate term. So we took out the highest common factor. So what am I left with? AD squared is equal to 2h squared over sine squared beta into 1 minus. Now cos 2 beta. Which one's got a plus 1 in it? Which one's got a plus 1? You know why? The minus times the plus 1 will give me minus 1. And minus 1 plus 1 will cancel itself out. So which one's got a plus 1 in it? 2 cos squared beta minus 1. That's your double angle for cos. Sorry? I don't know. No, look, this is generally, negative times negative is going to give me a positive. So let's use 1 minus sine squared. Sorry, let's use 1 minus 2 sine squared. Let's use 1 minus 2 sine squared. So we're going to use 1 minus 2 sine squared beta. You know why? Because the plus 1 minus 1 will cancel out in the next step. So we're now going AD squared is equal to, I'm moving over here to the side. We got 2h squared over sine squared beta into 1 minus 1 plus, remember, we multiplying the negative inside, plus 2 sine squared beta. Onliners, are you following? Are you following? This is equal to 2h squared over sine squared beta into 1 minus 1 is 0. We left with 2 sine squared beta over 1. So now AD squared will equal to sine squared beta, sine squared beta. 2 times 2 is 4h squared. Therefore, AD is going to equal to the square root of 4h squared, which is 2h. And that's your final answer. They wanted AD in terms of h. Yes, so much work just to get AD to equal to 2h. Onliners, schools, learners, can we do math online every day? 100%. Jabulile, yebo sir, katleho. Thumbs up, ji bhai, Razin ji bhai. Barabar, chokas, lemon sticks. Oh, hi, lemon sticks. Yo, people are already flirting here, bruh. Hala. Katleho. Well done. Gives you power. It gives you life. This is not Coke. Coke adds life. Kway adds life. Maths every day for free. You nice, ne? EFF, everything for free. Ratabile, Olifant, well done. Okay, we're done. Let's go. I hope you took it down, guys. Learn this. Very, very popular. You know what? I got a good feeling they're going to ask you about in this two-dimensional trigs. Just, you know what? Think cos rule. Think cos rule. If the cos rule doesn't work, then try the sine rule. Or vice versa. But sine rule, cos rule must come out in your paper. Okay, let's go. Let's go back. I'm going back to the previous frame. Ha, there we go. Take this one down. Take this one down. Take it down. They give you, let's identify, let's study the triangle. 6 marks.
Question.
Okay, let's see. 6 marks. Let's go back. Let's see what the question is. Mr. Kate, do karate. Why? Wax on, wax off. That's what I do. I wax on and wax off. You know Karate Kid. Maybe
Mr.
before your time.
Miyagi.
Mr. Miyagi. Yeah, maybe then I should have just made my beard and put a little. What's this?
No, you've got the look. You've got the look, Mr. K. Can channel some Mr. Miyagi.
Yeah, Cobra Kai. Ichni, Sanchi. Now I know how to count in Chinese. That's as far as I go. I did a little bit of karate in school, but nah. Maths is my game. I play mental karate, judo, mental judo. This is mental karate, blood sport.
Yes.
Let's go. Let's go. Let's go. Let's go. Find the value of x for 6 marks. I'll even tell you which paper this one came out from. Give me a second. June 2021. This is Department of Basic Education, June 2021. This is from your June 2021 paper. Okay, let's see. Now, what do we have here? Firstly, they don't give you any other information. Let's read the story. In the diagram, ABCD is a cyclic quad. AFB is 2x, x, and 3x. So basically, they're telling us ABCD is a cyclic quad. They're already helping you. Guess what? They're already telling you use the properties of a cyclic quad to answer it. See how easy is it? Right? Please, guys, get full marks in Euclidean. Get full marks in Euclidean.
You did.
Right. So you know what we have. What do we have? Let's identify. We got x here. We got 3x. So we know angle C1. We know angle C1 because this is a cyclic quad. We know this is a cyclic quadrilateral. Right? So we know C1 is equal to 3x. Right, so let's write it out. We're going to say angle C1 is equal to 3xy, the exterior angle of a cyclic quad. Exterior angle of a cyclic quad is equal to the interior opposite. Please, you must put your reasons. Okay, now we know that B1 in this triangle. No, I can go to B2. I can go to B2 directly. I can go to angle B2. Angle B2 is the exterior angle of a triangle equal to the sum of the interior opposite angles. No, but wait. X plus 3x is how much? 4x. So angle B2 is equal to 4x. Exterior angle of a triangle. Let me just highlight that for you. An exterior angle of a triangle equal to the sum of the interior opposite. It's equal to that plus that. So the exterior angle of triangle is equal to the sum of the interior opposite. Huh? No, now we're going to, so what you got? 4x plus 3x is 7 plus 2 is 11. No, 7, 11. 7 plus 7, 4 plus 3 is 7. 7 plus 2 is 9. So now we're going to go in triangle ABF. In triangle, all bloody fools. Right. We know that 3x plus 4x plus 2x is equal to 180. Sum of angles of a triangle. So 4 plus 3, 7 plus 2, 9x is equal to 180. X is equal to 180 divided by 9. X is equal to 20 degrees. Okay. So this is still dealing with your grade 11, little bit of grade 12 concept, but mainly this is a grade 11 question that's asked in grade 12. Also learn the proof of your theorems. Which theorems do you need to know? Line drawn from center of circle to midpoint of a chord meets it at 90 degrees. Exterior angle at center equals 2 times angle at circumference. 10 chord theorem. 10 chord theorem. And then exterior angle of a cyclic chord equal to the of a cyclic quad equal to interior opposite. Right? No. We're not getting, that's grade 11. Right, so your grade 11 content, please make sure you master it. Out of your 40 marks, your grade 11 work is 20 to 25 marks. That's last year's work. Now let's go into this year's work. Now, the main thing about you, I know you guys battle. And I know it gets a little bit tricky because the main thing you people don't understand when to use proportionality, when to use similarity. Right? Firstly, even from your grade 12 work, make a note, learn your proportionality theorem with parallel lines. You've got to learn to prove proportionality. That's book work. That's marks for free. That's marks for free. Right? And here, it comes out in the paper here, 6 marks. 6 marks. And just to show you what it looks like, you guys have got this one here down. Let's just show you what the proportionality theorem looks like. You know, it's a simple triangle. It's a simple triangle with a pair of parallel lines in it. So they can call this triangle A, B, C, D, E. And they're going to tell you that that line is parallel to that. So prove. They're going to ask you to prove that AB over BC is equal to AD over DE, right? Actually, even AB over AC, sorry, AB over AC. So let's just scratch this out. AB over AC is equal to AD over AE. So this is your simple proportionality. It's worth 6 marks. It's book work. Make sure you get. So out of the 25 now, so say you got 25 for your grade 11, plus you got another 6 here. It's 31 out of 40. You only got another 9 or 10 marks left now for your grade 12 component. You leave it for last in your paper. Okay, but in any case, let's go and do this one here. It's going to look a bit, we're going to do 2 nasty questions. I'm going to do 2 nasty. I can't do every humanly possible scenario, but I can show you how we're going to tackle it. And I don't have the memo here, so we're going to be trying to crack it by ourselves. Okay.
Question?
Yes.
Are we going to be doing statistics? Question by...
No, we're not going to be. No, there's nothing in statistics. The only thing that is there is your 1 standard deviation. I'll show you the higher order question in stats. I'll do it when we wrap up. Wrap up. Okay. Because come on, guys, that is all grade 11 work, mean, median, mode. The only thing you need to know now is your least squares regression line and your theta. That's all calculator work. Y is equal to A plus BX. And your line of best fit. Okay, and calculating the outlier. So let's go here. Right, let's draw the circle. Oh my word. Let's see what the circle looks like. Okay, it's a bit of a hectic diagram, so you're gonna have to draw it with me. So let's take it down. Okay, in fact, maybe don't start drawing now because I might make a mistake, but I'll try my best not to make a mistake, right? So let's say this point is here. Let's put a point here. And it goes straight across there. It goes straight across there. And then you've got another line that comes straight down here. So let's go from here. Let's go across there. And that's a tangent. That's a tangent there. So now you've got a tangent coming from here, coming down here. Take this down. Take this down. Then you've got a line. So that's correct. You've got a line coming from here, coming straight across, cutting here, right down to here. You've got another line just coming from there, straight down there. You've got a line joining these two in the circle. And I think that's the diagram. I don't think there's anything else here. I don't think there's anything else here. That's what your diagram looks like. Now let's label it. Let's label this diagram, M being the center of the circle. So there's M. M is the center of the circle. So obviously we know that this line is not a diameter. It doesn't go through the center. That is A. That is Q. That is X. It's always good to redraw your diagrams because it gives you good perspective to what sort of shapes are in your diagram. So you've got 1, 2, 3. You've got P. You've got A, 1, 2, 3, 4. 1, 2, 3, and 4. And then we've got angle C. This is angle C1, and that's angle C2. And we've got these two sides equal, that side equal to that side. So let's highlight that. And we've got one last thing. We've got this side parallel to that side. Although it doesn't look parallel, but they're telling you it's parallel. In the diagram, M is the center of the circle. A, B, and C are on the points. AC equals AB. We got that. AC equals AC. Oh, sorry. AC equals BC. Right, good. PA is a tangent to the circle. So they tell us that PA is the tangent. PA is a tangent to the circle. What else? PQ is drawn to CA to meet BA produce. BC produce PQ at R, and AR is drawn. Let angle Q equal to X. Let angle Q equal to X. Right, here are your questions. Determining giving reasons 4 other angles equal to X. Question number 1. They want 4 other angles equal to X. Other angles equal to X. And question number 2. Prove that ABPR is cyclic. Prove that ABPR is cyclic. And let's see the last question. So 6 and 2 is how much? 8. 8 and 3 is 11. So there's 11 marks on this question, guys. And question number 3, prove that BA over BQ. Now here they're asking you similarity again. BA over BQ is equal to BC over QR. BC over QR. Mark allocations. Let me give you your mark allocations. 6, 2, 3. 6 marks, 2 marks, 3 marks. 11 marks on these 3 questions. Now, before you get started, just to tell you when to use proportionality, when to use similarity. For proportion, when can you use proportion as a reason, and when do you need to prove that 2 triangles are similar? When can you use proportionality as a reason? Right? So this is just aside. This is not part of this question. These are just rules. P for proportion, P for parallel. So whenever you see 2 parallel lines in a triangle, you can use proportion. So P for proportion, P for parallel. So whenever you have parallel lines in a triangle, you use proportionality as a reason. You don't need to prove it. Whenever you have 2 superimposed, S for similar or S for superimposed, can you see one triangle on top of another triangle? S for similar, or if you have 2 separate triangles, maybe a S for superimposed or S for, so let's say S for superimposed means one on top of another, or S for separate. This will help you to remember. Whenever you see superimposed triangles or separate triangles, you got to prove similarity. Whenever you see parallel lines in a triangle, it can look like that, and it can look like this also, where they give you like this and like that. You always use proportionality as the reason. So P for parallel, P for proportion. S for superimposed or separate, S for similarity. Makes it right. So whenever a line, no, this is not the midpoint theorem. This is not midpoint. Midpoint, you know, from grade 10. Only if it goes from the midpoint of one side to the midpoint of the other side does it become parallel and half the third side in length. That's grade 10. This here is
Question?
proportionality. Yes. Will we do? Yes, we will. Yes, we will. We're going to try and push as much as we can in the time that we have. Inshallah. Let's say inshallah. We will do as much as we can in the time that we have. Remember, I'm doing all the main topics. The other smaller topics, if you feel, if we don't have time, then no stress. We've done it in our previous workshop. You'll just go to the Awqaf website and go to the previous day 2, where we did those topics in detail. So no stress. We're just doing the big topic. So let's do this one here. 4 other angles equal to x. So obviously these two lines are parallel, right? So I want 4 other angles. So let's answer question number 1. So let's do this. I'm blocking it off. Let's do this. Answer to question number 1. 4 other angles equal to x. So if this angle is x, then obviously A1 is x. That's the first one that came to my mind. Corresponding angles, because these two lines are parallel. So angle A1 is equal to x corresponding. Which two lines are parallel? QP is parallel to AC. So that's right. Which other angle can you see is equal to x? Why is angle B equal to x? Right. Now wait. Okay. All right. Wait. No, not equal chord sub 10. You know what we can do? There's an isosceles triangle. ACB. Triangle ACB is isosceles. So now you have to say AC equals BC, given. Therefore, triangle A, that's a triangle. ACBG. No, we're not using isosceles as a reason. We're proving isosceles. You are allowed to. But I could have said A1 equals B, isosceles triangle. Right? Which makes sense, but they don't want you. They want you to prove it. So that's what I'm doing now. I'm proving it. I'm not using it as a reason. So AC equals BC given. Therefore, triangle ACB is isosceles. Therefore, angle A1 equals angle B, which is also equal to x. The angles opposite the equal sides. I mean, it's so silly. I don't know why they make you go through all of this. But anyway, it is what it is. They want you to do it. You might as well do it. The angles. Yeah, you could say equal chords equal sub 10 equal angles. So angles opposite the equal sides of an isosceles triangle. So we've got how many? How many angles have we got so far equal to x? 2. Right. Now let's look. Of course, because that's at the circumference, A2 is equal to x. Tan chord. Yeah, the converse of the tan chord theorem. Therefore, angle A2 is equal to x, the converse of the tan chord theorem. One more angle, guys. Boom. P, alternate. These two are parallel. That's a transversal. Angle P is equal to x. It's alternate to A2. Done. And there we go, our first 6 marks. Our first 6 marks. Let's see if you guys did number 2. How are we doing, onliners? How are we doing? Are you guys following? You understanding? You know exactly what we're doing. Prove ABPR is cyclic. Prove that it's done already, guys. ABPR. Prove that ABPR is cyclic. It's done for you already. Watch. Let's highlight it. Let's highlight it. They say A, B, P. Whoa, that looks bad. Yeah. A, B P R. The R. Okay, relax, man. Yeah. ABPR. So to prove this to be cyclic, you can already see the scissor or the bow tie. That angle is equal to that angle. So this is angles in the same segment. So that's your answer. Boom, it's done. So let's erase this. Let's answer question number 2. Those of you who answered question number 2, I want you to start question number 3 already. That's now they're asking you to prove that. So now they're asking you to prove proportionality. So that means you've got to look for parallel lines. If they're asking you to look for proportionality, you look for parallel lines. Let's see. Let's answer question number 2. Let's answer question number 2. We're going to say angle. No, we're going to say, what you're going to say? QR equals. Can we say that QR equals to? Yes, you can. Yeah. No stress. Okay, no problem. I like your thinking, but carry on. I'm still doing this one here. ABPR is cyclic. So how do we write it out? ABR, angle ABR is equal to X. ABR is equal to X. APR, angle APR is equal to X. Therefore, ABPR is cyclic. Again, converse of angles in the same segment. The converse of angles in the same segment. So that's the answer for question number 2. Let's now go to question number 3. So where's BA? BA over BC equals to BC over QR. Okay, whatever happens here, guys, whatever happens, leave this last question out and fail. No, I'm lying. Whatever happens, we have to use triangle BQP. No, BQR. We have to, because the parallel lines lie where? AC and PQ. AC and PQ are your two parallel lines. So we have to use triangle BQR. So that's just a hint. That's just a hint. How many onliners did the last one already and it worked out? You worked it out. Okay, so let's hear what your reasoning is. Right, tell me your reasoning. I'm going to write your reasoning. So this one, I'm not going to give you the answer. Let's see what Tasneem wrote and let's see whether Tasneem's answer. I just put you there on the spot there, bruh. In the hot seat. In the hot seat. Wait. Let me erase this. Wait. Super math. Wallah math. Math. Right. Let's answer question number 3. So what did you say? In triangle. Right. What are you talking about? RBQ or BQR? BQR. Yeah, that one. BA. Right, good. BA over BQ. So wait. Just give me a second. Calm your farm. BA over BQ. Good. BA over BQ is equal to BC over BR. Fantastic. Is it? Wait. BC over BR. And what is the reason for that? Proportionality. Because there's parallel lines, I don't need to prove two triangles. We just use proportionality theorem. as our reason. Right. No. I'll give you the instruction to carry on. Let everybody take it down. Right. Now carry on. BR, where's BR? BR equals to QR. Right. Wait. One statement at a time. Right. So BR, this entire side is equal to QR. So she's saying BR is equal to QR. But now listen, pay attention. Why is she saying that? Now, because angle Q is equal to angle B. So that makes this big triangle an isosceles triangle. So now, but wait now, you can't say that. You can't say it's an isosceles. So you're going to say now angle Q equals angle B, which is equal to X. Therefore, triangle QBR is isosceles. Therefore, that's Q, right? That's Q. Therefore, BR equals QR. Therefore, BR equals QR. Okay, that's what she's saying. I'm writing down her reasoning. Right, let's see. So these two, right? Okay, so good. Therefore, BA over BQ. Right, so now let's go back. Give me a second. Let's write it out. Therefore, BA over BQ. Right, remember we had here BC over BR. So now what did you say here? BR is equal to QR. Right. BC, but BR, therefore BR is equal to QR, so is equal to, I'm taking that proportionality. There's the BC. Remember, there's our question there. BA over BQ, there we go, we got that, is equal to BC, right? There we go, we got BC. And instead of BR, I'm now going to put QR. Perfecto. Well done. 100% correct. Well done. Well done, Tasneem. Well done. Okay, now the next set of 3 questions are going to kill you. The next set are killers. Right? This is your grade 12 content. This is your grade 12 final exam content. Now, very likely when they're asking you here, you take your normal proportionality and then ask yourself what's missing, and something that's missing must equal to something that you have already, and you just substitute it. Whew. Okay, the next one gives me stress. The next one gives me stress. Just looking at it. Onliners, are we all okay there? Hasanain, we still live there? You still okay? You still alive and kicking? Right. I'm clearing this. I'm clearing that. Shoo-be-doo. Shoo-be-doo. Okay, so here goes. Right, take this diagram down. So, right, there's a big circle. There's a big circle. Take that one down. Now, I need to draw a smaller circle here inside. So, let's see. I just want to see how they... Okay, so there's that circle. I'm just going to move it down. Give me a second. Give me a second. I'm moving the small circle down. Let's try and make the circle a little bigger. Give me a second. Oopsie. Let's go there. Let's see there. Let's go there. Let's go there. And let's go there. And let's move the entire thing there. There we go. There's our 2 circles. Right, take that down. Take that one down. So we've got we've got this. We've got a line going that way and a line coming down that way. Let's see if S is the center. In the diagram, TSR. Yes, S is in the S is the center of the circle, right? So we got a line coming down here. We got a line coming down there. We've got a line going across there. We got a line coming there. There we go. There we go. Take it down with me. Then we've got from here going across there. Then we got a line coming down here. Then we've got a line coming across here. And then we've got a line going across there. There we go. That's the diagram. That's the diagram, onliners. That's the diagram. Let's put in our values. TMS. TMS. That line is parallel to that line. This is 90 degrees. This is R1 and 2. That's R1, R2. This here is P. This here is Q. And then that meets there. They all meet there. That's 1, 2, and 3. 1, 2, and 3. And then they've got S1, 2, 3. S1, S2, S3. Anything else given? No? Yes. M1, M2. M1, M2. There we go. There we go. Take the diagram down. This is point C, point T. Hasanain, we all good that side?
Yes, we're all good. We're pushing on. We are all marathon runners.
That's
we're here
it.
for the long walk.
That's it. We in
Stay
for the long haul.
hydrated. We're having water. We don't have those purple cows and stuff like that.
Right. In the purple, in the diagram, TSR is the diameter of the circle. So they tell us TSR is a diameter. Right. Of the largest circle having center S. Code TQ of the largest circle. Code TQ of the largest circle. Okay. Does it means PQ is a common tangent? PQ is a common tangent. PQ is a common tangent. PQ is a common tangent, and yeah, that's it. SQ is drawn. RP is 90 degrees to PQ. We've got that. MS is parallel to QR. We've got that as well. So let's just put S is the center. Yes. They say it's a diameter. TSR is a diameter. That means S will be the center. Circle with center S. Right, let's go. 3 questions here, guys. 3 questions. 15 marks. This is your last. So imagine you did everything in your paper and you got your full 25 out of 40. This is your last question that will account for 15 out of the 40 marks for your paper. Right. Prove giving reasons. Here goes. Question number 1. Prove that SQ is the diameter of the smaller circle. SQ is a diameter of the smaller circle. That is worth 3 marks. Question number 2, that RT is equal to RQ squared over RP. And question number 3, if MS equals 14 and PQ is equal to square root 640, calculate the length of the radius of the largest circle. Find the length of the radius of the largest circle. Let's put your mark allocations here for you. 3 marks there, 6 marks there, and 6 marks here. 15 marks, guys. 15 marks. 15 marks. While they're doing this, Hasanain, can I just put up the info for our weekend session? I'll put it up on a new screen. While you guys taking this one down, our Thursday and Saturday program, guys, it's a Kway program. It's online and in person. In person, I've only got 20 seats. The rest of you can come in online. There's my number. You can WhatsApp me, 081-706-3986. This is for Thursday and Saturday's program. The cost is 180 per day. 180 Rand per day. I'll just write it here on another screen for you. While you're taking down this, oh, let's clear that one. We had that one. So we've got our Thursday program and we've got our Saturday program. Thursday, we're doing paper 1. Saturday, we're doing paper 2. The cost involved for each day is 180 Rand. Please, you guys can contact me directly for bookings. I'll send you guys the link by this evening or tomorrow morning. It's 081-706-3986. You can book directly. I'll send you guys a link. You click the link, add to cart, book your seat, and you'll be in Thursday time. So Thursday time, we can start at 4 p.m. Too late. You can quit at whatever time you're going to quit. I'm going to push through till 9 p.m. One way, non-stop. Whoever wants to stay on, stay on. I'm just going to be working through past papers, heavy, higher order questions. You guys can all join the big study session. And then on Saturday, we start at 9 a.m. We can even go to about 4 p.m., 4 or 5 p.m. Let's even go 9 to 5. Okay,
Question.
paper 1, paper 2. Question, how many hours? So let's count the hours now. Let's go 9, 10, 11, 12. No, 4, 5, 6, 7, 8, 9. So there's 5 hours here. No, here it's 4. Yeah, there's 5 hours there. I'll even go till 10 p.m. So it's 5 to 6 hours. I'll even go till 10 p.m. Here we go 9, 10, 11, 12, 1, 2, 3, 4, 5. Here we'll do 8 hours.
Are you having a sleepover, Mr. K? I mean, be honest now.
Think
This
so.
looks like
I think this is going to be a
party.
sleepover.
Own up now. Own up now. Be honest.
No sleep. No sleep. No sleep. No sleep. Right. So it's 180 per day. You guys can book for both days. It's 360 for both days. 180 per day. 180 per day. And it will be obviously 360 for the 2 days. Yeah. Well, what? It is. No, but you are getting it at a better. You guys know what you normally pay for a day? 350 a day. You're getting it at half the price. Okay. But wait, that's not all. You're going to get Mr. K live.
You get a loaf of bread with that.
Then you get a loaf of bread. All right, wait, I need to go back here. So, guys, take this detail, take a screenshot of it. This is just the info. That's just the info. I'll keep the info up here. I'll put it up again before we conclude for today. Right, there we go. Let's see. Prove that RT equals RQ squared over RP. Where's RT? RT is equal to RQ squared over RP. No, RP. Hey guys, right. Let's go. Let's answer these questions. Let's answer question number 2. Oh, question number 1. We didn't even do question number 1. All right, let's answer question number 1. Prove that SQ is a diameter. Where's SQ? SQ. Prove that this line here. So let me just do a different color here, guys. Prove that SQ is a diameter. So the only way we can prove that SQ is a diameter is if we prove that M2 is 90 degrees. Right.
M1 is 90.
Right.
Q1 and Q2 is 90, man. Angle in the semicircle.
Right. In your bigger circle. No, it's fine. Okay, so let's hear. What's your reason? Q1 plus Q2 is 90. Am I right? No, it's right. Q1 plus Q2, because this is your diameter of your bigger circle. That's your diameter of your bigger circle, right? So Q1 plus Q2 is equal to 90. So angle Q1 plus angle Q2 is equal to 90. Angle in a semicircle, right? Angle in a semicircle. Then what did you say? And there we go. M1. M1. What did they say? All right. So M1. No, in fact, what you could say this is equal to 90 because co-interior angles. Oh yeah, same thing. Same thing. But it's fine. It's fine. These two lines are parallel. These two lines are parallel. So therefore, angle M1 is equal to 90. Therefore, angle M. So what did we need? Therefore, angle M2 is equal to 90. Adjacent supplementary angles on a straight line. M1, M2. Adjacent ADJ, SUP angles on a straight line. So now, therefore, SQ is a diameter because a diameter, it's the converse of your. If this angle is 90, therefore SQ must be a diameter. Therefore, SQ is a diameter, and that is the converse. That is the converse of angle in a semicircle. Angle in a semicircle. Very good. Lovely. You got your first 3 marks. So this SQ is now a diameter. We've now proved that SQ is a diameter. We're now going to go on to the next one. Now, because we're dealing with RT, we're dealing with RQ, we're dealing with RP. But now RP is out of this triangle completely. But where are our parallel lines? Remember, listen, we're dealing with RT. I'm looking for RT. There's it. There's RT. Then we're looking for RQ. RQ is in this triangle. That's in that. So basically, I'm still going to be... RP, don't worry about RP. RP is outside the triangle. Let's work with the triangle that got the parallel lines. So we're going to be looking at in triangle TQR. Let's do triangle TQR. So I'm answering question number 2. Onliners, how are we doing? How are we doing so far? After this, guys, after this 2 questions, I'm just going to do some polishing. It's already 20 past 2. I'll just give you that one higher order question in terms of that data handling, that one standard deviation away from the mean. And then I'll just explain to you the difference between your fundamental counting principle and FCP and factorials. And I'll give you some higher order, 1 or 2 higher order factorials or FCPs to do. And that will take us 2 to 3 o'clock today.
How's this comment, Mr. Khota?
Yes. I can smell smoke coming from my brain.
Oh my word.
Bruh, this is where we're burning it. This is where we're burning math. This is where we're burning math. Okay, let's go. Let's go. Hang in there. Hang in there. We almost at the end. Every time your brain tells you to shut down, you tell your brain, shut up. Hang. Blom. Right. We're answering question number 2. So we go in triangle TQR. Right. Let's go. In triangle TQR and triangle QPR. Right. So in triangle TQR, and triangle QPR. Oh, I'm going to move over. And triangle QPR. That's the way we did it. Right, so they split it up. So you got TQR. What you can do, split it up. That's Q1, Q2. That's T. That's R1. Then you've got QPR. Let's cut it out and put it on the side. QPR. Q, and that's Q3. That's P, that's 90. And that's R2. What do we have here? That's equal. All right, these two are equal, right? We know that's 90, that's 90. Q3, angle Q3 is equal to angle T. Good. Q3 is equal to angle T. So let's put a star here. Let's put a star there. Let's put a star there. Let's put a tick here. Let's put a tick here. Right. So let's go. Let's write it out. Number 1, angle, what is this? Q1 and 2. Q1 and 2. So angle Q1 and 2, Q1 and Q2 is equal to angle P, which is equal to 90 degrees. That's one angle. We need a second angle. Angle Q3, which we just now identified. Q3 is equal to angle T. That's angle Q3 is equal to angle T. Right, but wait, we said TQR. So now we have to say angle T is equal to angle Q3. Tan code. And what's your remaining angle? Now R1. R1 is equal to angle R2. And that is our remaining angle. Right. Therefore, triangle TQR. Watch how I do it. Is similar to triangle. Be careful. Watch here. Watch here. Watch here. TQR. TQR. The star to the square to the tick. The star to the square to the tick. Now we have to go star, square, tick. What is star? Q. What is square? P. What is tick? R. There we go. Right? So therefore, triangle TQR is similar to triangle QPR. Right. So we've done this. I'm moving over here to the side. I need to take, you've all understood the two. We separated them. There's two triangles. We separated them. So we had to prove similarity. Right. Now we go into the proportion. Now let's talk about the proportionality. So now let's go. We're not yet done. We're not yet done. So let's go into the, we need to get to this scenario. We need to get to that scenario. So what do we have here? We got RT, therefore RT. So where's RT? RT is there. Over RQ, over RQ, there we go, over RQ is equal to RQ, here in this triangle, RQ over PR or RP. And boom, there we go. It works. We cross multiply. We cross multiply. Therefore, RT is equal to RQ times RQ. Right? I just multiply this side by RQ. I multiply that side by RQ. I get RQ squared over RP. Not actually cross multiplying, over RP. And there we go. That's our final answer. And we get 6 marks for that. You, the last one is going to kill you. You work the last one now? Owens here, they are warm, bruh. They are warm. They're showing maths. They're showing maths flames here. The next one, that last one. Guys, that last one you leave for the last in your whole paper.
QR is 2 times MS because of the current. You have a
Yes. Right. I'm erasing this here on the top. I'm erasing this on the top. Right. Let's just see what they gave us. Let's put it here. We're almost there, guys. Hang in. Hang on. It's 2:30 already. We're almost at the end. MS is equal to 14. PQ is equal to root 640. Right. Find the length of the radius. They want the length of the radius of the bigger circle. So what's the length of the radius of the bigger circle? Either SR or SQ. So they want SR or they want SQ. That's the radius. Okay, I'm going to take that out. Your last 6 marks. Let's see if you guys got the 6 marks. We're almost there, guys. This is the last question that we're doing in Euclidean. And then we're just going to do some polishing. Remember, all the content, the basic to intermediate was, again, I'm telling you now, for those of you who just joined right at the end of the day, for those of you who just joined, all the previous content, the basic to intermediate was on the previous Okaf program. So if you still need some refreshing on that, go to the Okaf website and just pull the previous
Can
program
I show you that, Mr. Khota? Can I
Yes,
show you
please
that
do.
on screen?
Please do. Please show everybody.
So basically, this is the Okaf website, right? Awqafsa.org.za. So let's put that address there while Mr. Khota catches his breath. Awqafsa.org.za. This is the website you have to bookmark.
My ears are too big.
It's going to simplify things for you
It's
to
very
find the videos of the
Yeah, man.
previous
I
session.
need both sides.
So this is the homepage. On the homepage, there's something called Okaf SA Online Maths Workshop. You click on that, and that's going to take you to the event page for our current workshop that we've been conducting. So this is video for paper maths number 1. If you click on play, it will play the video, right? This is maths paper 2. You click on the play icon, it's going to play the video. And to assist you, what Mr. Khota was referring to, he was referring to maths paper 2, right? So these are the 2 videos. This is maths paper 1, and this is maths paper 2. So if you click on this, this is going to play maths paper 2, our workshop that we did in August 2022. So there you have it. Okaf SA's website has everything for your revision and your preparation for the final exam. Over to you, Mr. Khota.
Thank you so much. Jazakallah. Jazakallah. Like I said, guys, basic to intermediate, you need to polish yourself. Go back to the previous Okaf programs. Watch those. Then come back to this and try and master this again. Okay, so let's go. Now, here's our answer, guys. Here's our answer. TS is equal to SR. TS is equal to SR in the big circle. Why? They are radii. Right? S is the center of the circle. So that is equal to that. Now look at this big triangle. Listen to this. Listen to this. This is equal to that, and this is parallel to that. So this now becomes the midpoint theorem. This now becomes the midpoint theorem, right? Therefore, MS, remember, a line. So what is the midpoint theorem? What does the midpoint theorem state from grade 10? That a line from the midpoint of one side parallel to the third side goes to the midpoint of the opposite side, or a line from the midpoint of one side to the midpoint of the other side is parallel to the third side and half the third side. So here goes. Very important to what I'm saying now. So MS is equal to half of QR. This line here, MS. Muhammad Sadiq. Muhammad Said. MS is half of QR. Midpoint theorem. Take that down. So therefore QR now is equal to, I can manipulate this, times 2 times 2. 2 of MS. So QR is equal to 2. And what is MS? Of 14. They told us MS is 14. So 2 times 14 is how much? 28. So QR is equal to 28. So let's go. Where's QR? This is QR. That's 28. And they told us PQ is roots. Where's PQ? PQ is root 640. What do they want us? What's the radius, right? Yeah, so what you can do, you can say QR squared. You can say QR squared is equal to QP squared. QR squared is equal to QP squared plus RP squared. Pythag. That's this triangle here. Guys, I'm looking at this triangle here. Shh. I'm looking at this triangle here. So what's QR squared? 28 squared is equal to what's QP squared? Do I have QP? Right, there we go. PQ or PQ is root 640. So it's root 640 squared plus RP squared. So what's 28 squared? 784 minus 640 is equal to RP squared. So RP squared is equal to how much? 784. How much? 144. You sure, ne? So RP is equal to the square root of 144, which is 12. So this one here was the square root of 640. We use Pythagoras and we get that is equal to 12. Yes or no? Now from the previous one, what was our previous question? RT was equal to RQ squared over PR squared over RP. Right. So RT, I want RT. RT is the diameter. Remember, now I can find what the diameter is. RT. So RT is equal to RQ. Do we have RQ? Yes, 28 squared. Divided by RP, PR, which is 12. So what is RT? What is the diameter? $28 squared over 12 is how much? Okay, wait. RT is equal to, let's put it as 196 over 3, right? 196 over 3. Therefore, your radius RS, so RT is this. So obviously, we're going to take this and divide it by 2. Therefore, whether you want to say SR or you want to say SQ or you can say TS. Right. Therefore, your radius is equal to 196/3 divided by 2. That gives you how much? 98/3. 98/3 units. And there we go. There's our final answer. All right. Take this one down. Take this one down. Let's see you can do this standard deviation question. Come.
It's the last one.
Come. Let's see if you can do this higher order standard deviation question, right? Yeah. Do you guys remember it? Yes. Onliners, how are we doing? Right. We're doing some wrapping up now. I want to do that higher order data handling, just the one where they give you one standard deviation away from the mean. Inshallah, we're going to cook maths. Guys, we're now just doing polishing, guys. We're just doing polishing now. Basically, the show has ended. Our 2 days are over. I'm just giving you... Yeah, I know. Caleb, I know your brains are finished. Relax. But check the next one. Right, finish this. Euclidean, your brains are fried, I know. Right. Watch this. Watch this. Watch this. I hope you guys took all this down. Can I clear the frame? Have you guys taken it down? Give me the green light. Give me the green light. Give me the thumbs up. Can I clear the frame? You survived, brah. Lemon stacks, you survived, brah. Alhamdulillah. Alhamdulillah. Right, here goes. Relax. Right, let's clear. Right. It is given that... Let me clear the frame. Let me clear the frame. Let's go. Here goes. Here's that question. It is given that it is... Take this one down. It is given that P and 103,59 is the interval of 15 random learners' marks within one standard deviation away from the mean. I must congratulate all of you for sticking it out for 2 solid days. We won big Kway and Okaf family. Welcome to the Kway Okaf family.
Simonye, we are one.
There's it, he's losing it.
Getting it back.
You're getting
Where's
it back.
Hannah? Where's Hannah?
Anna
People asking,
Montana
where's
didn't come in.
Hannah?
I know people were asking.
And
Anna Montana didn't come in today. She might be online.
Who's that other guy that you use? Jomo.
Jomo
Is Jomo
didn't.
coming?
Jomo is online, bruh. Jomo
He's
is
a figment
online.
of our imagination.
Yeah, no. Jomo is real. Trust me, Jomo is real.
Oh, God, help us.
He's our imaginary friend, guys. He's our imaginary friend. Right, come. You done? Yeah, you took down the question. Right. Shh. Right, here goes. It is given that P and 103,59 is the interval of 15 random learners marks within one standard deviation away from the mean. If the average is equal to 60, if the mean is equal to 63,96, find the value of P. So this point P and 103,59. I'm helping you to get the answer. They tell us is, okay, this 15 random learners is immaterial. That you just forget. Within 1 standard deviation away from the mean. Right. So that means this is your mean. Your x value is mean minus 1 standard deviation. And this 103,59 is your mean plus 1 standard deviation. So here, let's look at our y value here. So our mean plus 1 standard deviation is equal to 103,59. They're telling us mean is 63,96. So 63,96 plus 1 standard deviation equals 103,59. So your mean, your standard deviation is 103,59 minus 63,96 gives you how much? 39,63. Now we need P. We need the X value. So P is equal to your mean minus 1 standard deviation. P is equal to 63,96 minus, you found your standard deviation of 39,63. Your P is equal to 24,33. And there we go. That's your answer. You'll get 4 marks for that in your final exam. You leaving now? Okay, bro. Good luck. But I'll see you Thursday or Saturday. Right. Either online or live. Okay, inshallah. Okay, guys, that brings us to the end of that. Let's do FCP, Fundamental Counting Principle, and let's do some factorials. We did it in the previous session as well. We did it, and then probability. We did it in our last workshop that you came for. And we did it online, and I did it on TV. There we go, there we go, there we go. Just for everybody here. Guys, we at the end. I just want to show you guys the difference between fundamental counting principle and factorials and the types of questions that you could see. Right, so let's go. Let's go. So we're taking this one out. Right. Fundamental counting principle. You're not multiplying. You are not multiplying all the way to the number 1. Here, you have 4 spaces, a 4-digit code. But you got numbers, 0 to 9. So you got 10 numbers. But you only got 4 spaces. So your numbers, your options is not equal to your number of spaces. Your options is not equal to your number of spaces. So that is called fundamental counting principle. We just multiply. So an example of this, how many 4-digit codes can be written from 0 to 9? So 1, 2, 3, 4. We can choose 10 numbers here. 0 to 9 is 10. We can use 10 numbers here if with replacement. So you either get with replacement or without replacement. So with replacement, 10, 10, 10, 10. So obviously you just multiply. FCP. So we're not saying 10 times 9 times 8 times 7 times 6 times 5. That's factorial. When you're multiplying all the way to the number 1, that becomes factorial. And that's where your number of spaces is equal to your number of options. Please learn this. Write this down. For those of you who don't know it, take it down. I'm not going to ask you to calculate anything. I'm just telling you now to take down notes. So this is 10 to the power 4. This is 10,000. You get 10,000 different arrangements. And what is the probability of you getting it right? The probability of the event that you getting it right in one try is 1 out of 10,000. And that's a fundamental counting principle. Now, a factorial would be in how many ways In how many? So an example of this, in how many ways? The minute they say in how many ways can eight books be arranged? Now these are 8 different books, but sometimes they can use a deck of cards and they can put their 2 hearts, 3 diamonds, and 4 flowers. Clubs. Yeah, flowers. We say flowers. We old school. We still say flowers. In how many ways can it's still factorial, eh? But that's just the grouping model. So in how many ways can 8 books be arranged? So that is 8 factorial. Why? Because you got 8 books. 1, 2, 3, 4, 5, 6, 7, 8. You got 8 spaces and you got 8 books. Because in space number 1, you got 8 books to choose from. Space number 2, you used 1 book. So you got 7 books to choose from. 6 books to choose from. 5, 4, 3, 2, 1. That is factorial. And 8 factorial, let's go to our calculator. 8 factorial. What the hell did I do there? Right. 8 factorial. What do I get? 40,320. 40,320 ways. But they definitely going to ask you about grouping and arrangements. So now let's talk. This is level 1. Example 1 here. This is level 1. Let's go to level 2 and level 3 style questions, which definitely you're going to see. Now where they start grouping values. So these 4-digit codes, please play around with them. Work through your past papers. They can even tell you a 4-digit code. The first number must be a 5. Listen, it must be greater than 500, but it must all be even. So play around with your different combinations. You want to play around with one like that. Let's say the first number, it must be greater than 5,000 and the numbers must be even. It's easy. So let's say you got 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the numbers you have to choose from, right? They want a 4-digit code. It must be greater than 5,000. But the number must be even. In how many different... So definitely this is FCP. This is not factorial. Right. Greater than 5,000, that means the first number has got to be a 5. Because this could be 5,002. Right. So we took one number out and with repetition. So you are allowed to repeat. Right. In the second one, how many options do I have? I've got full 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 values to choose from. In the second one, how many values do I have to choose from? Again, 9 values to choose from. And in the last one, remember, it's got to be even. So now I can only select even numbers. 2, 4, 6, 8. 1, 2, 3, 4. I can only choose 4. So 5 times 9 times 9 times 4. That is FCP. 5 times 9 times 9 times 4. Boom. 1,620 different arrangements. Now they can say this was with repetition. Now they can say without repetition. So you can play around with the different styles. Okay. Let's look at a higher order factorial. I'm going to do 2 higher order factorials to wrap up today. I'm doing 2. Guys, we're at the end now. Just listen to me. I know your brains, you can shut off also. It's fine. Just write. At this point in time, just write. These are notes I'm giving you. Right. Please. And guys, you cannot come on Thursday and on Saturday and come to me with basic questions. You're wasting my time. Don't waste your time. Don't waste my time. Don't come there and ask me, sir, what is the formula for SN? Why did you use the arithmetic? Yay. You are dead meat. By this time, you should know your work, know your formulas. Right. Let's do a higher order. Come. Let's do a higher order factorial. Right. They tell you, here's the question in the exam. Consider the following alphabets. Consider the following alphabets. Namakwaland. Namakwaland. Right. In how many ways? No, calculate the probability. Here's it. Now it's a higher order question for 6 marks. Calculate the probability. If you don't know your basics, I'm telling you again. Go back to the Okaf video of our last workshop. Calculate the probability that a word chosen, will start and end with an N. With an N for 6 marks. So here's your higher order question number 1. We're going to do higher order question number 2 and we are done for today. So just work with me here, guys. Work with me. I know your brain, you've switched off already. Some of you now are just finished. Now you're just zooming now. You're just going with the flow. You're boosting now. It's like that 1 o'clock spin on a Saturday night. Your bras are talking, you spinning like this. You coming home now from a skirt and you just like, okay, all right. All right, I'm going off to it. Hey, it's 10 to 3 already. Right. Okay, our auntie, you want me to do it for you?
Yes.
Oh, I hate you. Yeah, I love you too. All right, let's go. So it needs to start and end with an so now firstly 1, 2, 3, 4, 5, 6, 7, 8. How many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it must start with an N, end with an N. Right. So first step number 1, you got to calculate in how many ways can the word be arranged. So step number 1, you got to take 11 factorial divided by all your repetitions. So you got 2 N's multiply by 4 A's multiply by 4 A's. That's all, ne? I got 1 N, 2 N's. How many A's? 1, 2, 3, 4. I don't have anything else. That's it. So 11 factorial. Firstly, we need to calculate our total available factorials. Total available combinations. So our total available is going to be fraction 11 factorial divided by 2 factorial multiplied by 4 factorial. You got to eliminate all your repetitions. So you got 831,600 ways. That's your total available. Now, step number 2, that's why it's 6 marks. Step number 2, in how many ways will it start and end with an N? So now how many factorial do you have? You got 9 factorial because you took out the 2 N's. And what did we do here? We only got 4 A's left. Yes or no? Because I took away the 2 N's from there. So 9 factorial divided by my 4 A's. 4 factorial. 15,120. So that's step number 2. Please do it like this in the exam. So this is step 1. This is step number 1. This is step number 2. Step number 3 is how we answer the question. Right? Right. Calculate the probability now only. So the probability of the event, of it starting and ending with the n, is 15,120 divided by your total available 831,600. Here's your final answer. So 246 marks divided by 831,600. 1 over 55. Your answer is 1 over 55. One more, guys. One more. No, we're doing one last one before we leave. Come on. Last one. Last one. No, it's 2 minutes. I promise you, I will. Wait, relax. Let them take it down. It's 5 to 3. We got 5 minutes left. Come on, you sat here for 2 days. You're crying for 5 minutes. So they can chill. No, let them tell each other how much they love each other. At least 5 more minutes. 5 more minutes. 5 more minutes. 5 more. We there, guys. Here's higher order number 2. Right. Higher order number 2. Right. Last question for today. Higher order number 2. Right. A student has 5 poetry books. 5 poetry books. 4 language books. Oh God. 5. That's a 5. 5 language books. And you've got 2 literature books. Right. If 3 poetry books need to be placed next to each other, 3 poetry books need to be placed next to each other, in how many different ways can the books be arranged? In how many ways next to each other? I'll finish the question now. In how many ways can all the books be arranged? This is the last question for today, guys. Yeah, it's been 2 days of math insanity. But you guys did it. You guys did it. And you guys were part of setting a world record. You can stay. And how many can what needs to be placed next to each other? 2 literature books. In how many ways can the books be arranged? In how many ways can the books be arranged? Let's go. How do we answer a question like this? And this will take us to the end of today. 5 and 4 is 9 plus 2 is 11. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5 poetry books, 4 language books, 1, 2, 3, 4, and 2 literature books. 2 literature books. Right. If 3 poetry books need to be arranged, so any 3, you can group any 3. So let's group any 3. Right. In how many ways can the books be arranged? So what you do now, you put a tick, you count the number of spaces available. 1, you count the entire group as 1, 2, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 factorial. Multiply by the number in the group because they can also swap over. So multiply by the number in the group. So it's your number of spaces your number of spaces factorial multiplied by your number in the group. So what's your answer? 9 factorial times 3 factorial? 2177280. 2,177,280 ways. Right, give it 1 minute, guys. We're almost there. Right, just to give a final thanks, Jazakallah, and thank you all for coming in. We had a bumper 2 days. You guys will never forget us, hopefully, for the rest of your life. You'll know how much effort you put in before your final exam. To all our 200, 300,000 learners online, I just want to say Jazakallah. Thank you so much. Lots of love from Kway and Okaf. Hope you guys enjoyed our session and hope to see you guys on Thursday and Saturday, inshallah. So master all the work. A big Jazakallah from Kway to Hasanain. The program would have not gone so smoothly. My captain, my co-pilot, Hasanain from the Okaf offices in Cape Town, Department of Education, Mr. Mudau, Uncle Zainul Kaji from the CEO of Awqaf South Africa, and all the participating learners, teachers, and schools in South Africa. Lots of love, lots of love. Good luck, study hard, and inshallah be the best. See you guys soon. Follow us on Instagram, Kway Institute, Mohammed Khota on Facebook, and follow all my posts. I'll add you guys all as you guys send me messages on WhatsApp. I'll add you. You guys can follow all our statuses that go live on a daily basis from us and our studios here in Johannesburg, South Africa. Assalamu alaikum. Good afternoon. Tot ziens. Hambagatle. Salagatle. Sizobonana pambile.
Okay, Mr. Khota, stay with us here. We're going to be sharing some information.
Hey, there's some cash prizes.
Yeah, so we all can agree money is too tight to mention. Money is too tight to mention. So this is why we're having a competition, right? And this competition is going to award the learners that have performed excellently, right? There's 2 or 3 categories. First place, second place, third place, and most improved. We will be emailing all of the participants. There is a form, but the form is only going to be activated by December. After your examination, we'll activate it. So all that you need to do is you need to submit your July results and your December results. And we want to gauge if this workshop has been helpful and has assisted you in the program.
What are the prizes? Besides cash prizes, are there any other prizes that are also available?
Look, I'm sure we will throw some nice prizes into the pot also without mentioning anything. Definitely some tech products that the learners can use going into university and post-school work. So I would like to do a vote of thanks would like to give a vote of thanks to you, the learners, for attending the session. It's very important that you attended the session. So for your dedication and your time, we salute you. You've been a fantastic cohort, and we've definitely been vibing over the last 2 days. And some of the learners have also joined for the August workshop. Teachers across Mzansi, we respect you. We salute you. Educators, administrators, for making lots of these sessions happening from the bottom of our heart. You see, this is progress, Mr. Khota. This is progress.
Amazing,
this is progress.
Amazing.
This is progress.
This is
learners
so amazing.
Using a smartphone in a classroom, and the resources are limited, but they're putting their best foot forward. Would like to thank the Awqaf SA team. This has been a team effort. Lots of the Awqaf team have been quite involved. Would like to thank the Department of Education, especially Mr. Leonard Ndau and the rest of your colleagues and your departments. You have ensured that schools across South Africa have been aware of this workshop, and you've been very instrumental in assisting us to assist and upgrade improve the grades of our grade 12 learners. Would like to thank Champion South Africa, the driving force behind that, Ashraf Gada. Hey, Mr. Khota, you know Mr. Ashraf Gada from Special Assignment, from SAFM, from 5FM. We had
He
like
used to
a
be on
team
a
of
702 as well, if I'm not. He's on Salam Media at the
100%.
moment.
Yes, 100%. So we had Mr. Ashraf Gada asking the learners, what is your purpose? And thank you for your engagement. You've definitely
Alhamdulillah.
assisted quite a lot. Would like to thank Mr. Khota from Kway, the driving force behind this program. And I think we worked very well together. And ultimately, we want South Africa to be great, awesome, better than the average, right? And we love you, our grade 12 learners. We love one and all. We are behind you all of the way. We want you to do very well because you are the future of South Africa. So that's it, Mr. Khota.
That's it, co-pilot. We've taken the space shuttle into orbit yesterday. We launched together from control room there on Earth to the orbit that we were in space, the Maths orbit, and from the moon.
Okay, Mr. Khota, let me try and see if I can scroll through some of these comments, right? There's just so much. Let's see, let's get to the part here towards the tail end so we can.
Cerebrum is done in your medulla oblongata.
Yes.
From the medulla oblongata into the olfactory receptor. Good luck, Iman. We're gonna kill paper one. That's the spirit. Mohammed T, we're going to bang this paper like Khabib. Smash him. We're going to smash him. We're going to talk like the Russians. We're going to smash him. Gracias, Bronadine. Thank you, Mr. K. Thank you. Suleiman, Bronadine, Kotlejo, Peño, Modise, all the best to everyone. We see you guys
This
again.
cohort has been lit, Mr. Khota. They brought it all, eh? And
They brought it. What a powerful group.
It's like I can't leave you guys. You guys have just been absolutely amazing.
Alhamdulillah. Have you got time to send all 10,000? My bum hurts.
I'm sitting on
the
Do you know, Mr. Khota, it's after 2 days. I'm sure your brains must be toasted. But hey, lots of these comments and feedback, like I'm also tired and fatigued. I have to go and do some shopping and whatever. But lots of this feedback that we're getting from our future, our grade 12 learners, this makes it all worth it.
Alhamdulillah, everything just makes it absolutely worth it. Lots of love, good vibes. Peño Modise, Tam Rangwato, Nokti, Utamaleng, Mata, Shaida Abrams, Sobia Farouk, Top G, Nokti, Nakedi Mabeda, Onalena, Mata, Paseka Lebuso, Notando Dube, Daud Kanchi, Mata, Ratabile Olifant, Mapadimeng Peño. Hey, I'm just going through all this. Botla Cello, Alhamdulillah. Botla Cello, we'll meet for lunch anytime.
Yes,
On me.
It's a deal.
Daisy M, Tabi Seng Baloy, Let's Do English, Nakedi, Rachel, Pamishka, Inshallah, Amin, Ramna Rains, Kim Sam, Kanye Si Banda, Azra, Afro Chronicles, Razin and me. Lemon Stacks. My man, Lemon Stacks. Who will forget Lemon Stacks for today?
Lemon Stacks has been huge, large and
distinction content. Hola.
Yeah. So
you got this, guys. You guys got this. My prize, I don't want a prize. My prize is to see you getting distinctions. Pagamiza.
I just want to see us rise to the next level there. We just want to rise to the next level. We want to
Alhamdulillah,
take lots
laptop
of our
looking
learners
nice.
out of
Fantastic,
poverty.
fantastic. Thank you,
And
everybody. Thank you for not being trolls. Thank you for all the
yeah,
good comments. Thank you for joining us. Lots of love here from Kway and from Okaf. And yeah, I think I'm out of studio, Hasanain.
yes, all the best.
I
Thank
just
you
want to
so
say
much.
Jazakallah also. It's been always amazing working with you, bro.
Yeah, no, it's real. And look, if we can make a change and we can
Alhamdulillah.
make an improvement, I just want one scientist to come out of our code, one doctor, one Elon
One
Musk,
good
one
engineer,
IT.
somebody to run ESCOM, somebody to run the water
Yes.
plant.
That's all. Then our
That's
job
all.
is
One.
done.
One. We just need one.
Yeah,
One
yeah.
brain.
Yeah. So that's
One
it.
main brain.
Yeah. So that's
Anyway,
it.
we're wrapping
guys.
up. We're packing up. Jazakallah. Thanks, Hasanain.
Okay.
From
all
me,
the
Mr.
best.
K, we
Would
out of
like to-
studio. Assalamu alaikum.
Wa rahmatullahi wa barakatuh. Here we go. Okay, that's it from myself, Hasanain Abdullah, and Mr. Khota here. Thank you for joining. Would like to thank all of you. All the best for your examinations. We wish you all the best. And with that, we'll be wrapping up. Assalamu alaikum wa rahmatullahi wa barakatuh, and good afternoon to you. Thank you so much. Thank you for joining.
T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care.